Good evening. Hope y'all can hear me. Welcome to our summer star party for the Fort Worth Astronomical Society. It's a little bit loud here. We have a bunch of crickets. We are out here at the Rising Star Observing Area. This is our new dark sky site. It is in Bortle 2 skies. It is very dark, not at the moment, but we are getting there. The sun set around 8:40. It is now 9:30. It is considered right around another 10 minutes. It'll be civil twilight, and then we'll have astronomical twilight. Or it'll be, sorry, about 9:40. It's the end of civil twilight, which means it'll be, for most intents and purposes, dark nighttime. But astronomical twilight ends, I think, about, astronomical twilight ends at 10:15 or so. So we still have some time until the skies get really, really dark. It's clear. It was cloudy before. Right now, it's getting there. We're getting there. Because it has not gotten dark yet, we have not had time to set up the telescopes. They're set up. They haven't been polar aligned. We're not quite there yet. We will be soon. So that's the next task. In the meantime, we're kind of just waiting. So I think I should be able actually to do polar alignments right now. I'm not completely done setting up all the cameras. There's one more thing that I want to set up. But we have a lot of people here. We're actually located between Cross Plains and Rising Star in Eastland County. And we have people here from Cross Plains. We have some of the public here for a night of observing. And we have several astrophotographers out here with their own rigs. They're going to be imaging most of the night for some of them. Some will be done about midnight or so and will be heading out. And we have some visual observers down on the opposite end. So we have several Dobsonians here. These are large aperture telescopes. They're purely visual, but you can see quite a bit here. The skies here in Rising Star are fairly dark. This is a Bortle 2 sky. So we have a range from Bortle 1 to Bortle 10. I don't remember if there's a Bortle 0 or not. If there's a Bortle 0, it's going to be in the middle of the ocean. No lights all around. A Bortle 1 sky is a very, very dark site. This is something like Big Bend in West Texas. This is something in the middle of Utah, out in the desert, far away from any cities. This is sites like Mauna Loa in Hawaii. In fact, much of the Big Island can be considered a Bortle 1 site, where it is very, very dark. There aren't many people in Hawaii, and there is, most of it is around the edges. And around Mauna Kea, we have observatories. And in Mauna Loa, there were some observatories. They're still there, but access is blocked because of the 2022 eruption from Mauna Loa. So the telescopes on Mauna Kea, they're very, very dark skies there. It's one of the best places on the planet to observe from. We have the Atacama Desert in Chile. It's also very, very dark there. Bortle 2 is one step up from that, a little bit brighter skies. We can still see the Milky Way very, very clearly. In fact, we can see some clusters naked eye. We can see some nebula, just a little bit of faint fuzziness if you have really good eyesight. And on really dark, moonless nights, the Milky Way can cast a shadow. The summer Milky Way, about 2 a.m., it's really, really dark. The Milky Way is as high up as it goes. It will cast a very, very faint shadow in very dark sites. As you go up from there, Bortle 3 is a rural sky. Bortle 4 gets a little bit brighter. Once you hit about Bortle 6, those are 6 to 7, those are suburban skies. And 8, 9, 10 is considered urban skies. Bortle 10 would be, you may see the moon, you can see the planets, and only a couple of the brightest stars. Think of this as downtown in a very, very large city, New York, Los Angeles, Houston, Chicago, Paris, Tokyo. The step down, Bortle 8, Bortle 9, this will be in smaller cities or the outskirts of of larger cities where you can see several stars. But you're definitely not going to be able to see the Milky Way. You can see the planets and the brightest stars. You can make out some constellations. You can easily see the Milky Way. You can make out most of the constellations, but only just. We're very fortunate that we have these dark sky sites like this, specifically this site for us. We used to have several others. We've lost them over the years, and this is the land that we purchased for our club that we will have it for as long as that we can. Okay, so if you have any questions, go ahead and put them in the chat. I will be monitoring them as best I can. It is warm. It has been hot today, and I have not had a drink yet, so I've got to drink as much as I can. Okay, again, if you have any questions, go ahead and let us know. Put them in the chat, and we'll go ahead and work that out. In the meantime, I'm going to set up one more camera so at least I can talk, and I think I need another cable to get this thing running. So bear with me. I will try to talk this through. We have people walking around, and again, we will do the best we can here. So I've got, if I can get a better light so I'm not bothering everybody. There we go. So I have a red light that I can use to see, and that's what we're going to stick with is the red light. So I will probably kill this red light even further. All right, what do we have? We have a couple constellations coming up. What I wanted to do is plug one of these cameras in and see what we can see just looking out as the sky is getting darker. Not right at the moment. It's like I have 100 things to finish up and not a whole lot of time to do it. Honestly, it would have been probably better to go ahead and do this at 10 o'clock once everything gets super dark. But in the meantime, I'm going to do the best I can. Let's see. All right. Okay, I'm going to have to get a helper to help me do something on here because I cannot do this alone. Yeah, I definitely can't do this alone. So I will start prepping some of this stuff and getting this ready. So what I need to do, what I'm going to be doing right now, is getting two. All right, let me describe what I have here because it is a little bit complicated. I am running at least two telescopes. One is a 11-inch Edge HD Celestron Schmidt-Cassegrain, and it is running a Hyperstar, which takes it from an f10 to an f1.9. And what that means in layman terms is I have a big, wide aperture, and I'm going to be able to take really fast images. On the other side, I have another 11-inch, and this is the Club 11-inch, and that one is actually set up so that I can do a close-in imagery. So it's actually set up as an f6.3. Excuse me. Ooh. It's seltzer water. Excuse me. So with that telescope, I will be able to do things like galaxies. We want to be able to hit some galaxies early on when it gets a little bit darker in the west. This is west. I'm currently facing north. Telescopes are all facing north. I want to be able to pick up some galaxies before they drop down too low on the horizon with the f6.3 scope, and with the wide field, we're going to start looking at the Milky Way. We're going to start looking at some nebula. I have a third scope. I don't know if we'll be able to use it yet. I want to be able to get at least one of these up and running so we can start doing some imaging, and then we'll get the other scope set up, and then we'll go to the third one. So right now, I am not sure which scope I'm looking at. Okay, I got it. I think I've got it. I'm going to switch those, but I think I got it. We'll deal with what we got. So I have a pole master. Let's do this. That telescope is going to be set up here. So we're going to go camera 2. No, wrong one. We're going to go to here. Okay, so I've got, and where am I? Here we go. Where am I? Hello? Uh-oh. I do not see myself. Maybe here. Nope. Nope. All right, let's fix this. There we go. Now you see me. All right, cool. So this one computer is hooked up to one mount. I have to go align that mount, get it ready, and get Polaris here in the field of view. Once I get Polaris in the field of view, I can then align the telescope and make sure it looks right. Okay, that way the axis of the telescope of the mount is pointed at the celestial North Pole. It's actually a little bit off of Polaris, very close, but a little bit off. And what that will let me do is then be able to guide properly. We'll be able to use the telescope and do tracking, and we'll do everything with it. I just have to get that set up. So here's what I'm going to do. I'm going to flip the laptop around so I can see it over there. I will try to talk my way through it. How many people show up there tonight? Christian is asking. I didn't count. At least 30. We have 1, 2. I want to say we have 10, 12 from the club are here, and then we have at least 20 have come from the general public. Incidentally, we do have a dome here. It is not fully set up. When it's fully set up, we will have an automated system with a RASA 8. This is similar to the one scope that we'll be messing with in just a moment, just a little bit smaller. It'll be on an automated mount, automated camera, automated dome. So our club members will be able to reserve time on it, connect in remotely, use the telescope, do imaging off of it, and then come back and download all the images and then process them remotely. So I'm going to jump over there. I'm going to turn the mic around so I can talk through, and then I will also move this around, I hope. Maybe. Oh. Maybe. So I can see. All right. This will be hard to see. Okay, but am I looking at Polaris? First things first. I will. Yeah, that's my fault. I'll take the camera, put it down. Now I will shine a laser. There is Polaris and my laser is blue. That's way up. Okay. Now I will need to fix that. So I know you can't really see what I'm doing. That's okay. I am trying to get all this stuff aligned. It's really hard to see right now, but unfortunately, this is the only time I can do it. Okay. What? Okay. Close. Ah. So the laser will go off. I will put the camera back on. And once the camera goes on, you'll be able to see Polaris. Hey, there's Polaris. Polaris is the bright thing right there in the middle. Ish. All right, that's my mouse. This is Polaris right here. So, yep, let's do. You see Polaris. Click on Polaris. Cool. Now I can use. This is such a neat tool that makes polar alignment so much easier. Success, yes. Use the same one. Okay, double click Polaris. Have to center it. Here we go. Cool. I was close. I just have to move Polaris right to there. Now, come to the back, and I start jiggling with some knobs. Right direction, wrong direction. There we go. Now, it's hard to see from a distance. That's too far up. Okay. Right, let's move it down. Okay. Okay, where is it now? Nope, too far down. It's really hard to see from a distance, sorry. Okay. Yeah, it's just super hard to see from a distance. Trying to get everything looking right. There it is. Okay. Yeah. There it is, off to the side. Yeah. Next. There we go. Hey, that's pretty good right there. Okay. Cool. You know what? That's good enough. Uh-oh. You know, I forgot to do. I have seen it. I forgot to balance this thing. Let's balance it first. So, after I do the polar alignment, I should just be able to, let's see, where is it? Yep, okay. Access. Double click on player. That's pretty close. Yep. Finished. Let's see. Yep. There we go. Success. Start monitor. You know what? That is so close. I will take it. With the laser, with the pole master, it makes it super, super simple, super, super fast. Okay, next, actually we can almost start imaging. I just have to balance it. So one moment while I balance. Let's see, this thing. There we go. So, wow, oh yeah, so we can start imaging in a few minutes. Right after I balance it. Okay, balance this way. So I have to balance it in two different directions. First, whoa, yes, that is not ideal. Way too heavy in that direction. Almost there. That's balanced in that direction. Okay. All right. Lock this down. Hello. That would be me that you're seeing. Out of focus, but it's me. Okay. Next, I have to bounce it in another direction. Let's see. Oh wow, that's so front heavy. Okay. So this is trickier because I have to release the telescope. I'm sorry you can't see this. It's super dark anyway. There's not really a whole lot to see. Unfortunately, it's the summer. It just takes a long time to get dark. Right? It's still not balanced. Oh, that was a little bit too slidey. Okay. Almost. That is close. Okay. Next is the scope back. Where it's not one thing, it's another. But it's fine. You know what? That's good. That will work. Okay. I do believe we have one telescope that is ready to go. All right. Turn this guy around. Get this out of the way. Get that out of the way. All right, here we go. Okay. Let's see. Any questions? How many people showed up? Yep. All right, cool. All right, let's do this. Finish this. We'll disconnect it. Close this off. Get a sharp cap. All right. So, oh boy, here's what I got to do. Connect to that guy. My focus should be close. Oh. Okay, that's fine. Ignore that error. All right. This, I have to change all my settings here. So let's do that. We're using a totally different mount. We got Optron mount, and we're using the ZWO focuser. Okay. And no filter wheel, no rotator. Let's make sure we can connect to it. Yay. Nothing to configure anymore. Excellent. Properties. Hoping this works. Hoping this works. There we go. Excellent. Hit apply. We've got mosquitoes out here, but they are not bothering me. Apparently, I do not taste good to mosquitoes. All right, let's do this. We'll do raw 16. And we're going to switch it to output type. Fits. We don't want movies. 50-second. We need more than that. Let's do 1 second exposures. And I need to turn my cooler on. Minus 10 degrees. So, let's see what we got. What do we got? Hey, we got some dots. Okay. It is time to focus. I got a 1 second. Let's pump up that gain way up there. Cool. Hey, we got stars. There's Polaris right there. Okay. We've got stars. That's not bad. All right. Now, I can do this. Optron. Unfortunately, everything's going to be on one monitor. That's fine. Totally not worried. Com3. Yes, it sees it. Oh, I'm so happy. Okay. Uh-oh. I was happy. Auto detection. Did I forget to turn on the mount? I may have forgot to turn on the mount. Let's do that. Turning on the mount would have been a really good idea. So let's see. Let's see if it works now. I just... Okay. We're going to do something else. You know, when we're doing astrophotography, one of the things that often happens is stuff just doesn't work. It just doesn't. And so what do? Deal with it. And we just deal with it. So instead, I have the camera here. It's connecting. Let's just do it off of here. Let's see what happens. Okay. So I have let me rephrase that. I have two setups with telescopes, two mounts, two laptops, each of which should be controlling one of the mounts. Let's do a 2 second exposure. Make that big. All pretty cool. Here we go. There we are. We have Polaris. Oh, hey, there we go. Satellite. See that little trail there? That's a satellite. Right through here. So this is a polar satellite. What that means is it orbits from North Pole to South Pole, back to North Pole to South Pole. As it orbits, the Earth turns underneath it. This allows polar satellites to see every single spot on the Earth eventually. Where normal satellites that orbit around the equator, like geostationaries, they're over the equator, and then satellites like the International Space Station are angled to the equator, so they go up a certain distance and then down a certain distance, but they don't go over the poles. And we use polar satellites for lots of stuff. Mapping is one of the big things, because they can see every single part of the Earth. So when we're looking at Polaris, we can see these polar satellites fairly often. When I'm doing the polar alignments, usually every other time I do it, I see a satellite. And just having the scope pointed out towards Polaris, right here, lets me see satellites like we just saw a couple seconds ago. All right, so thermal controls, let's turn on the cooler. Let's get the temperature of the camera down. The lower the temperature on the camera, the less noise there's going to be. The less noise there is, the nicer the image is going to be. Now, here we go. Let's see if I can connect. Let's get it set up. No. Okay, so here we go. Let's change sharp cap settings. My focus is probably halfway decent. I don't think it's perfect. That's fine. We can fix it. I literally just updated all this stuff. I had an issue last week when I was doing testing, and I had to completely redo all of my stuff, all my software. Oh, there's another. Oh, wow, that's a bright one right here in the background. It's a fast mover too. So that means it's lower. If it's moving faster, it's in a lower orbit. If it's moving slower, it's in a higher orbit. There we go. Okay, I think we're going to be good for this. Apply. Hit OK. All right. Connected. Please connect. There we go. Let's see. Will auto detect? Anything? Anything? Yay. Here we go. All right. Mount panel. Cool. I'm going to drop these down to my secondary monitor so it's out of the way. And we're going to see roughly where we are. So this is set up. This is set up. Cool. All right. It is tracking. We are good. It thinks it knows where it is. And next I will do this. I'm going to do a plate solve. I should do a plate solve and resync, but cool. Let's do a plate solve and resync just so it knows where we are. What this does is the software is taking an image of the sky and figuring out based on the stars where it's located. Ooh, that's pretty. As long as it knows where it is, I'm happy. Okay, now I can actually come in and we can find some targets. So let's go look at some galaxies. It's pretty much dark enough. Let's go to Messier 99. Let's do Messier 99. Let's just do that. Slew. And we're going to go to the Messier catalog. Messier catalog. And we're going to go slew to 99 and confirm the slew. Okay. Now all the stars are moving. Just zoom it across. Now, I don't know how accurate this is going to be. That's fine. We will do another plate solve. Once we do the plate solve, it adds in additional information into the mount, and the mount says, okay, now I know where I am. So it is moving to the west and the north, which should be fantastic. And I know the image is still a bit green. Hopefully we'll be able to clear that up a little bit. Okay, do you see any galaxies? I see no galaxies, but I'm only doing a 2-second exposure. High gain, but 2-second exposure. That's not that much. Let's figure out where we are. We're going to do deep sky annotation. And let's do a quick plate solve. So the deep sky, we do you mean you can't find a solution? That's not good. There's another satellite. All right, let's do plate solve and resync. That's not good. Interesting. Plate solve only. Okay, cool. Wait. I did the plate solve. Okay, so it knows where it is. All right. Nearby. I don't know why it's doing that, so let's find out. And I can do my plate solving. And what am I using? Built-in plate solver. Let's use that one. Cool, cool. See what happens. Might take a bit longer to do, but it's going to figure it out. It should be figuring this out more accurately. This is a really, really neat technique. Why can't you find this? This ain't good. How about this? Start looking at stars. That may be easier. I'm going to name stars, and let's do Vega. This 200. That's Roswell Hogg. 240. 240 tourists. 240 something. Vega 244. There we go. Let's do confirm salute. Let's go find Vega. That's interesting that it couldn't do the plate solve. That's okay. The night is young. It is only 10 o'clock. I plan on being here until I can't stand it anymore. Yep. Oh, wow. It tried to plate solve off of streaming stars. Okay. Please solve it. Too many stars. Okay, well, that's something I can fix. Let's do that. Let's take my gain way down to... Maybe that's it. Maybe there's just too many stars. And instead, I will do a slightly longer exposure. Let's just do 4-second exposure. And I guess we need a little bit more gain. Okay, how about this? Let's see what it can find with these stars. And by the way, this is a... There we go. Too many stars. It doesn't know what it's doing. Try it again. It was able to do it. I'm just... I don't have this issue from the city. Reducing exposure and gain. Okay, let's try the standard one. Honestly, this is exactly like what astrophotography is. Sharp solve. Okay. Gain 50. All right, well, we've got that. Oh, no wonder. Yes.
Is yours ready?
Is what?
Yours.
Oh, I'm trying to get something. We're about to see if we can get Vega.
Where's that? What's
Vega
that?
is a bright star over there.
Bright blue?
There we go. See that bright star right there?
Bright blue?
Ish. Okay. Plate solve again. So what I'm doing is I'm telling the telescope to figure out what I'm looking at. So there's Vega. Now it knows where Vega is, and I'm going to resync this one more time. So it puts Vega right in the middle. So now it will know what we're looking at. There we go. How's that? Vega right in the middle.
Can we look at it through your telescope?
No, everything is electronic. Everything is with cameras hooked up so that we can see it on the screen here.
Way better.
By the way, you guys are live on YouTube right now.
What do you mean?
See that camera up there?
I don't think you can see me.
If you move, yeah, actually you can't. Well, yeah, there. Say hi, say who you are if you want to. You don't have to. Okay.
Why am I posting this on YouTube?
Because this is a live star party that I'm doing.
Oh yeah, and everybody won't get to see it.
Not everyone can come out here, but
Whoever's on the whole other side or far away.
they can see it. We have people from everyone on chat. If you want to type in where you're from, I know we have. I think someone here. I think I know who that is coming in from Hawaii, and let's see who else. Ooh, that's bright.
Yeah.
So there we have Vega. All right, so we can see Vega now.
Right.
Let's go ahead and see if we can jump over to. I'm going to go to Messier. Neptune's going to be hard to see, especially with that telescope. But what we can do is this.
Oh my.
Let's see how this works. So we're going to jump over to Messier 99, which is a galaxy. And actually, I should bring this up right here.
Oh my, it's dark. Because
Oh,
of
yeah.
this bright setup.
Yes, unfortunately, that's absolutely true. So here is...
Oh my, the universe is massive.
It is. So here's what we're going to be looking at. We're going to look at Messier 99, galaxy. We'll jump over to it. And where is it? This is located in the western sky, out there-ish. And it's a little galaxy like this. Okay. So we're still slewing over. Well, it's a little in the field of view. Mars won't be out until early in the morning. I think most of the planets aren't out until early in the morning. So now we're waiting. Next exposure.
Are you going to be out here till Mars comes out?
I will be out here until probably until the morning. All right.
At what time?
Oh, I haven't. Probably when the sun comes up. So we have one galaxy right here, but this is not where we should be. So let's rethink.
So you're going to be out here a couple of hours?
I will be here until the morning.
Yeah, that's a bunch of hours.
That is a bunch of hours.
So you're going to be streaming for all of it?
Oh, oh wow, look at all these galaxies all around here.
You're going to be streaming for a while.
Oh, yeah. I've done 12-hour streams before.
Dang. Oh,
yes. So,
have you done 24? Wait, is...
You want to think about that question? Have I done the night sky for 24 hours?
Wait, yes, you have.
You want to think about that question?
Mm-hmm.
Okay.
No.
M99. You sure? All right.
Yeah. Have you?
No.
No.
Why have I not?
12 hours?
Why have I not streamed for such a long period of time?
Have you done 12 hours?
I've done a 12-hour sync, yes.
What's your longest?
Scott, 12 hours. Okay, so right now what we're doing is a 1-minute exposure and gain of 100. Settings look okay. We have a 1-minute exposure. What this will let me do is get a whole lot of light into the telescope. Once a whole lot of light gets into it, onto the camera, we'll have a much clearer image about what we're seeing. And then this will do a live stack. And what the live stack does is it takes one image and takes another image and puts it on top of it. Takes another image, puts it on top of it. Takes another image, puts it on top of it. And it builds up the image. And this is the way we average out all the noise. Okay.
Nice.
What do we see? I don't see nothing.
Black.
Why don't I see nothing? Oh.
That's over 1 million stars.
How's that? Look at that. We have, hold on, look. We've got galaxies here. We've got a galaxy here. We've got a galaxy right here. We got a galaxy right there. Okay. Now, what we're going to do is we're going to let it, actually, the chip hasn't cooled down.
Wait, can they see what we're seeing?
They're seeing everything that you can see on the camera. So you're right there. They can see you. See? And they can see that. So what I'm going to do now is I'm going to zoom in.
Oh, that looks like the sun.
Yeah, it's
what
not...
kind of bugs are those?
What? Oh, I don't know. Probably mosquitoes. So there we have a galaxy now. We have this going on. I don't like that. So here's what I'm gonna do.
Yeah.
PhD2. We're gonna use PhD.
Andrew, it's going fun, Dad.
Oh, it's already running? Oh, sweet. Okay, fine. PhD stands for Push Here Dummy.
No, it doesn't.
Yes, it absolutely does. It absolutely does stand for Push Here Dummy. And it is a way for us to use a separate camera and separate telescope. And now, let's close that. Let's go ahead and do this.
Andrew. It's going fun, Dad.
And that, oh, that's not even in focus. Okay, you know what? Here, y'all watch this thing. Okay, see that big fuzzy thing?
Big circle?
Yep. Here's what I need you to do. I need to watch that and tell me when that big fuzzy circle gets down to a little bitty point. Okay?
Is it get down to a little bitty what?
Is it fine if I sit right here?
Is it getting bigger or smaller?
Smaller.
Smaller.
Oh yeah, way smaller.
You get a point? You see a bunch of stars, or is it still kind of big?
Oh, it's about that big. Oh yeah.
Can you see a bunch of stars?
No, I can only see that one little bit.
All right, hang on. Sorry, you have to move over. Okay.
Set it mess up.
No. Okay. There we go. Let's make this bigger. It'll make it bigger to see. Okay. These need to be smaller. Okay.
Okay.
Then when they get really small.
Like where I see like a bunch of stars.
Smaller.
Yeah. Getting there.
Getting there.
It looks like it's getting bigger.
Bigger?
Mm-hmm.
Okay.
Okay, it's shrinking. Good.
Smaller or bigger?
Smaller.
Small.
Now?
Big.
What?
It went from small, big, small. Big. Smaller. Bigger. Big. Small. Big. Small. Big. Small. Small.
Okay.
Straight line.
That should do it. Okay, cool.
Andrew, should we go inside, Dad?
Nice. 1017.
Oh, jeez.
Is it really 1017?
Hang on, move on. Yes, it's 10:17. Okay.
We're
So-
gonna go find my dad.
All right.
What's up?
Okay, so now I need to train the mount. This shouldn't take very long. So what I'm doing right now is I'm telling the mount, that's why it's called Push Your Dummy. It sends a signal to the mount from the computer saying, go in a westerly direction. And once it's done, it'll go east. And then it'll go north, and then it'll go south. Once it happens, it knows what direction to push the telescope to when the stars move out of the position that they're at. It's a neat little technique, and this is called auto-guiding. So we'll be able to, once this is on, the telescope will lock onto a star, and we'll be able to take longer exposure images without that streaking that we saw earlier. So right now, when you go back to the image, there's a lot of this streaking. And so these should be a point, and they're not. In fact, I'm going to turn this off because, Then we're going to go down to a 15-second exposure. I'm going to make this brighter because I want to see some details in this, but we're still starting with auto guiding. Ooh. Okay, I see where some people are. I know you're not from Poland. That's my wife. I know she's home. And let's see. T Corona Borealis. Yes, we'll be able to see T Corona Borealis. Unfortunately, it's a little dot. So last weekend, I spent some time imaging T Corona Borealis, as well as taking a spectrum of T Corona Borealis and Pallas. So what I was able to do is see just what light is coming from it by taking the spectrum. I have a special filter, a spectroscopic filter that spreads the light out into a rainbow. And by analyzing that rainbow, I can see what elements are there in the atmosphere. And then from there, I can actually identify what type of star it is. So I have my before nova images and my before nova spectrum. And now we'll be able to, once the nova happens, I'll be able to take a second spectrum, a post-nova spectrum, and we'll be able to compare what the differences are and make a video out of that. Okay, so Messier 99, it is noisy, but hey, we got pretty decent stars. That's not bad for stars. And let's see what PhD is doing. PhD tracking quite nicely. Is it great? Yep. Axis are questionable. Ooh, yeah, that's. Oof. We may have to redo that, but we'll see. Okay, we'll keep it for now. We're not doing anything super heavy duty, but let's go ahead and get the live stack and deep sky going. All right, so I want to clear out all the frames. Let's get the next frame. And I want to drop this thing down because I don't need all that. That's super bright. Let's fix our histogram. There we go. Okay. New stack of M99. All right. Let's do auto. Let's see what we can see. All right, so we've got galaxies here. Looks like it could be a galaxy here, galaxy there, galaxy here. I'm not sure what that is. Could be another galaxy, could be another galaxy here. If we do deep sky annotation, that will tell us, well, it's a little bit off. Okay, so galaxy here, that's a galaxy, that's a galaxy. Let's plate solve only. Let's just do another plate solve. There we go. Now we're locked in. Okay, galaxy, 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 galaxy. M99, that's a star. HIP, that star. Galaxy, another galaxy. Galaxy, that's a galaxy. Another galaxy down here. More over here. Everywhere we look. So right now we're looking out of the Milky Way. The Milky Way is currently close to the eastern horizon, going to the south, and then going all the way out to the north. So think of it going from the north out a little bit, about 20 degrees off the horizon right now, to the east, and then down. So when we're looking to the west, we're looking at almost 90 degrees out. This is we're looking outside of the galaxy when we're looking in this direction to the west. And that's where this is. So when we look outside the galaxy, we're not looking through a lot of dust clouds. We're not looking through nebula. We're not looking through a sea of stars. We're seeing a few stars out here, and then we're looking at galaxies. And that's really what we want to see, at least for now. So M99, this is a big old spiral, magnitude 9. And let's just zoom in on some of this stuff so we can see. So as you can see with the live stacking, the image is getting better and better every single time. A new image comes in every 15 seconds. The image clears up. The noise is going away. You can see it's getting a little bit better each and every time. And some of these stars here that were hidden in the noise, we can actually see. Oh, there's a satellite trail right there. Lots of satellites. But that's what we got. So some of these here may not be stars. I'm not 100% positive. Let's find out. Because they may not be stars. They may be clusters in the galaxy. Isn't that what we're looking at right there? Press again. Other direction. Stuff like this. This is part of the galaxy that we're seeing. These don't look like they're stars in our Milky Way. A bit too faint. quite a few galaxies here. Let's go up. There's a faint galaxy right there. Yep. Another one over here. Another one over here. NGC 4208, NGC 4212. Two galaxies in this area. So this is a nice little spiral here. Additional, wow. Okay, we're seeing more and more galaxies. Look, this is a galaxy here. These are galaxies. Here's a galaxy. There's a galaxy. That is likely to be a galaxy where here's another one right here on the edge. Okay, these are all very, very distant galaxies. They're very, very faint, but they're definitely there. Two more over here. One, two. This is just that blue thing right there. That's just a hot pixel. I'm not worried about that one at all. All right. Go down. More galaxies. And some of these aren't even labeled. That one's not labeled. I'm pretty sure we can find it in the star charts, but this one's not even labeled. On here, at least. But we have more. These are pretty faint galaxies. And remember, this is a 15-second exposure. What we would typically do for stuff like this is, with most telescopes, it would be a 5 to a 10-minute exposure to get this kind of detail. We have 11 inches of aperture we're dealing with at f1.9, super fast telescope, lets in a whole lot of light. We can take really short exposures and still be able to find these types of objects in the field of view, where in a much, much smaller telescope, much slower F ratio, we wouldn't be able to see this kind of stuff. There it is. Just nothing but galaxies. Now, look, galaxy, galaxy, galaxy. Anything else? Maybe some of this fainter stuff. Not sure. I'm not going to call it a galaxy if I don't think it. Oh, what's that? That looks like a galaxy behind that star, right next to it. Now, I don't know if y'all have paid attention to this, but there was an article a couple of weeks back about possible Dyson sphere candidates, and what they were looking at were stars that were a lot hotter than they were supposed to be. So they were looking at dim stars, but a lot hotter in infrared. And they found, I think, like 6 candidates for possible Dyson spheres. Basically, the idea of Dyson sphere is, so you have a star, and you want to be able to capture all the energy from the star, all the light, and turn on electricity. Well, how do you do that? Well, you put on a lot of... First, you start off with just big old solar satellites. So giant solar panels around the sun, picking up the energy, and then beaming it out with microwaves to a station where it converts it to electricity that you can actually use. Great idea. Well, let's start capturing more and more of the light. So you surround it with satellites, with solar panels. Well, that's cool and all, but what if you surround it with a shell of material? So what you would do is you would basically break down every single planet in your solar system into raw materials and build a shell around the star at 1 AU, or actually whatever the distance from it is, where the surface will have liquid water. So the Goldilocks distances. So they're looking for these candidate stars. Well, they found 6 of them. And they thought, well, these could be Dyson sphere candidates. And instead, another paper just came out saying, yeah, probably not. What they actually think is going on is that they're hot dogs. And by hot dogs, it's a hot, dust-obscured galaxy. So it's a galaxy behind the star. Just happens to be like, it'd be a galaxy like this, but there's a star in front of it, and then behind the star you have a dust cloud. So it's from our point of view, it is our eye, a star, a dust cloud, and then a far, far distant galaxy. Infrared light passes through dust clouds. Hubble can't see through dust clouds, but James Webb can. Because James Webb can, we're using James Webb because it is an infrared telescope to see through dust clouds and see the stars in the dust and beyond the dust. So instead, what we think that is happening is that, or the more mundane explanation for for this type of an object is a galaxy that's hot in infrared, hidden by dust, so we can't see it visually, but it's making that star appear to be a lot hotter in infrared than it actually is. So, no, we haven't found aliens yet. But we do see 3, 4 galaxies. 1, 2, and this is a galaxy pair right here. So let's do this. This is a 15-second exposure. I'm going to switch this up. Let's get deeper. Let's do, let's do a full 60 seconds. Let's do a 60-second exposure. Let's see how much detail we can pull out in 60 seconds. So I'm going to do, we'll leave it like this. Let's see what happens. So we've stacked 39 frames, which is pretty cool. 15 seconds. I'm super impressed. Uh-oh. Where is the white balance button? Yeah. Is that it? Nope. You know what? It's been a while since I had to mess with this thing. Background subtraction. Let's do. Here we are. Simple offset. Where is it? Mono binning. Nope. Temperature. Coolers on. Image control. Here we go. Brightness, white balance. Let's auto white balance it. No. No. Auto. Says it's auto white balancing. How about the brightness? No, we gotta wait. Let's see what happens. Yeah, the I can tell you right now, yeah, it is hard to read on there. Part of it is also the way it's going across to the other screen. Okay, let's see if I can fix this somewhat. Technique 2. Here we go. Fix this. Oh. How's that? That may be a little bit easier to read. Okay, 60 seconds. I'm going to clear this out. No, maybe not. Brightness filter. Yeah, Glenn, lower right into stacking controls. Oh, okay, lower right. Lower right, here we go. Auto stretch, what's this? Auto color. Yeah. Oh, that's, oof. Okay, then let's fix the histogram. There we go. Ah, that's somewhat more visible. If I turn off. Yeah, see, at this point we can barely see any of these. So we do want to punch it up a little bit. M99. All right. Auto color balance. Let's do it from star colors. That might be a little bit better. Okay. And there we go. Okay. That's going to be somewhat better. Let's zoom in again on M99. That's not bad. That's not bad at all. You can see some I can see some additional detail. And remember, this is a wide field telescope. Once I get the other telescope up and running, that one should be a lot better. I'm going to see if I can get it. If I can get this thing running. Let's see. Sharp cap settings. Hardware. Not Ioptron. We're going to do Celestron telescope driver. ZWO focuser. Oh. I needed a polar alignment on that thing. The other telescope isn't. The other scope and mount isn't even ready. Okay. Stretch on the live stack. How can you stretch on the live stack? Auto stretch. Yeah. That's not. Yeah, I think that'll work. Stretching mode. I have no idea what this is. There we go. Let's get this back down to about 1. No. Oh. Huh. Maybe this will work. Okay. I have not done the live stacking. Typically when I do stuff, I just go ahead and do straight imaging and then I do processing later. This is actually pretty cool. Thanks, Glenn. I appreciate it. I am always happy to learn something new. There we go. Oh yeah. Now we're seeing some galaxies. That is cool. That is pretty cool right there.
Someone over there is watching you.
Me?
Yeah.
Oh no.
No,
People are
watching
watching me.
your podcast.
Ah. So how does this look? Does this look better?
Yeah.
Lots better?
Mhm.
What does that look like? What does that look like?
A universe?
It's a galaxy.
I
We're-
forgot that name.
We're in the universe.
Oh, I forgot.
Yes. And the universe is possibly part of a multiverse, an entire cosmos. So we
I
use the
forgot
word
name.
universe to describe, well, let's start from the beginning. We sit on a planet. The planet is in a solar system. Our solar system orbits the galaxy.
Come on.
The galaxy is part of a local group. The local group is part of a local supergroup, local cluster. Local cluster is part of a local supercluster. The local supercluster is part of a much bigger cluster, which sits in the universe. And the universe may be one of many universes in an entire cosmos. And we're one of trillions of galaxies.
Gee.
Yeah, we thought they were like hundreds of millions, and now we think there are trillions of galaxies.
100 trillion.
So many, many, many
Billions?
galaxies. See all these round things? All the round bits here? All these round and oval ones, all of these here are galaxies.
Oh, dang.
Yeah, and there's actually a lot more that aren't labeled, but that we can just barely begin to see. At least we were seeing them on the other stretch. I'm not certain how much we can see. This one, let's see. It's time to go to bed.
No, we're about to go.
How old are you?
I'm 9.
9. I have an 8-year-old who's watching right now at home. And he's probably not terribly thrilled because he would rather be here.
Is he watching you?
He is watching right now.
How far away is
It is 10 o'clock. It is his bedtime. But that's okay. He can stay up late today.
How far are you from here?
I'm from Fort Worth, so we are 2 hours away.
That's not bad.
Not bad at all. Okay.
But we have to just 2 hours.
Yeah, there's that. Okay. Well, we had a little bit of a jump there. But we still are able to see these. So that's not too bad. That's not bad at all. We have a galaxy. We can easily see this is a spiral galaxy. I can turn off the annotations. Yeah, if I have to, I can turn off the annotation. And now we're just seeing the galaxy itself. So we can see the spiral structure. Here's one arm. Here's another arm. So this is the kind of stuff that you can see from a dark sky site that is very, very difficult to see from the city. There's just so much light pollution that this just gets washed out. Now we can use filters for some things. So for example, I can use a filter that only lets in a very, very narrow bandwidth of light that nebula give off when the hydrogen gets excited by ultraviolet radiation. And that's great. You can use those in the city. But this is a galaxy. And galaxies are made up of stars. Lots and lots and lots of stars. Millions, hundreds of millions, even billions of stars. So by using those kinds of filters, we're blocking a lot of the light from that galaxy. So I do have a filter that is supposed to be able to help with that. It's specifically for galaxies and reflection nebulas, things that are or that don't glow from emitted light, but a reflection nebula. Sorry, something's biting my foot. It gives off light that's reflected from stars, and galaxies just give light from stars. So, but here in our dark sky site, I don't need those filters. So this camera only has a built-in IR and UV cutoff filter. So chips are really sensitive to infrared light, and they're really sensitive to ultraviolet light. But if we use the ultraviolet light, then we get some haze to it. Or if we let in the ultraviolet light, we have haze. If we let in the infrared light, the stars get bloated. We don't really want that. So it has an IR UV cutoff filter, and that lets us get really good images, really clean images. And in a dark location like this, I do not need any other filters to do this sort of imaging. Now, this is not, let's get this centered out again. I want to find M99, F400, let's go 200, somewhere over here. Where's M99? There we go. Messier 99. And we're seeing additional definition in the galaxy here. Say, what are we seeing? We see a core. We can see the spiral arms. That is really cool. And these are with 1 minute exposures. So total exposure, 19 minutes, 44 seconds. And I'm now, yeah, it'll be like 20 minutes, 44 seconds. So I have a 20-minute exposure, and I'm seeing this kind of detail in the galaxy. Now, if I switch to a different telescope, I should be able to see a whole lot more. But that one ain't ready yet. I got to go over there. I got to do polar alignment. I think I have the balance. Yeah, I think I balanced it fine, at least in one direction. I'll have to double check that. But right here, this is pretty cool. I'm pretty happy with this. I'll give it another minute or so. At least this is a really good introduction to what you can see at a dark sky site. Now, one thing you cannot see on your screen right now is the sheer amount of bugs covering my laptops, my screens. Nothing but bugs, and I'm hoping none got into this can. If any did, just protein. Nope, no bugs. Excellent. Okay, Christian's asking, what cameras are you running tonight? I have an ASI 2600, and one of our other club members let me borrow a 2600 Duo. They're both color cameras for the other scope. And then I have a third scope, which who knows if we're going to get that thing up and running today. That thing is running a ASI 183 color. So, yeah, lots of cameras. But these are, the one we're looking at right now, this is an APS-C camera. It cools down pretty well. I'm pretty happy with the performance. That looks pretty good. I didn't have to change the focus. I didn't have to fix the focus. I probably should have, but honestly, this is pretty good. So I'm going to actually stop the. Let's do save. Let's save it. Cool. All right. So now I have that thing. Cool. M99. I got a time. 16-bit, 52 frames, stacked out. I'll be able to do something with this. I don't know what yet, but we'll do something. Be able to see a bunch of galaxies. but this is a fairly wide field of view. This is a really wide field of view. If you want to know, with the Hyperstar on here, it went from an f10 instrument to an f1.9, and now I'm down to about 550 millimeters of focal length, but it's an f1.9. So if you think about it in camera terms, it's a long telephoto, but it is a super wide or a huge aperture telephoto. So I have a lot of pretty decent resolving power with this, but it's just such a deep image because I can take this kind of exposure. Now, if I wanted to sit and do a 5-minute exposure, we could easily do that. We would get a very, very deep image out of it, but we'd be waiting 5 minutes. So it is now 10:45. That is pretty cool. 10:45, and if I look out and over, I have no, I have no sense of anything. My eyes are not dark adjusted at all because these are bright monitors. That's fine. We'll deal with it. Instead, we're going to jump over to the Milky Way. Does anyone have any suggestions on what we can look at? Because I was going to jump over on Antares and look at the Rho Ophiuchi area just around it. I'm not sure how much we'll be able to see. Let's find out. We can always test it. So let's do that. I'm going to go ahead and do another save. Just did that. Then what I can do is this PhD. I have to, even this is fine. I will have to stop it. I will go ahead and loop it and then come back down. We're going to go to Messier 4. Okay. Confirm the slew. Messier 4 is a globular cluster that is located right near Antares. And we're going to go back to here. Ooh, I don't want that. Let's close this version of SharpCap off. Get this one up. And we're going to do a quick 1-second exposure. Clear. I'm going to say M4. M4. Okay. And not M42, M4. No. So I guess we have so many bugs. I found many bugs in my equipment from last time I was here. Okay, let's turn off live stacking for the moment. 1-second exposures. Okay. Here we go. 1-second exposure. Got to go a little bit deep in that. Let's do 15 seconds. And oh no, no. 2-second exposure. Because now we have to do a plate solve. Figure out, are we pointed where we should be pointing? Plate solve only. Okay, are we looking at the right place? Let's do deep sky annotation. Whoa, Rho Ophiuchi. Okay, cool. We're close. Let's do plate solve and resync. Okay. Recentering. They're about 3.76 degrees off. Okay. Okay. Cool. Ready? M4. We got 2 globulars right there. Ooh, globular cluster. Okay, let's go deep. Frame rate. Nope, that's fine. Let's do, I think from 2-second exposure, let's just go to 30 seconds. 30-second exposure. And we're going to turn on live stacking. Deep sky. And then we probably want to go ahead and, you know what, before I do that, clear that. And no. It is not M42. It is in fact, okay. There we go. It is not M42. It is, in fact, M4. M42 is the Orion Nebula. Okay, we're going to do life stack. I'm going to turn this off. Okay, 539.6 millimeter focal length. There we go. Ooh. Have some nebulosity here, some clouds. You can see there's a lot of stars here. We're looking almost in the Milky Way. We're just a little bit off of it. And this globular cluster is not in the Milky Way. It is past the Milky Way. So we're looking through a sea of stars at this globular. And here is another globular out over here. So what we're seeing is several 100,000 stars. Bleh. Let's do let's see if we have to redo anything. Let's clear that. Start tracking. If it gets ugly, we'll just fix it. Oof. Clear. Yep. I think it'll get ugly. You have to resync it. Oh yeah. So we'll do this. Stop. Stop. Pick a star. Recalibrate. Alright. M13. We can do M13. Let's see. Let's see. Okay. Sorry, deal with this. Okay. Well. Okay, it figures something out. Let's see. Ooh, doesn't like that. Definitely didn't like that. So let's try it again. Okay, let's pick that star. Let's calibrate off of it. Yep. We just have to let it do its thing. Once it does, it'll be fine. In the meantime, it'll look like this. So the globular clusters, these are old. We think they formed about the time that the galaxy formed. Need to clear these two. So they're composed of pretty old stars, and what happens with them is because the stars aren't orbiting a black hole in the middle, they're not orbiting some massive object. They're orbiting each other. They're orbiting a common center of gravity, and so the closer it goes in towards the center, the more likely they are to have a close encounter with another star. Well, what happens is one tries to overtake another one. Is it a doggy? Hang on. Yep, I'm pretty sure that was one of the dogs that came by. So where we are out here in the country, the neighbors, hi, how you doing? You remember me? I think this one remembers me. So the neighbors' dogs are work dogs. So they are out here and they are quite happy to get scritches all night long. And this one remembers me from the last time. When I was out here with my son, the dogs were out and they just sat around. That's all they did, just sit around, and they just watched us, and they were quite happy to be here. So they got head rubs and scratches, and here's the other one, and super, super happy. Hi. They're just making sure that everything is okay. And if the coyotes come by, they bark. So it can be a little bit jumpy at night when the dog is right next to you and he starts barking. But other than that, they're absolutely fine. Now we're seeing some details. Cool. We're getting good guiding. We're seeing some details. Let's zoom in. So we have 2 globular clusters in this image. Okay, that's not great. But, let's clear it out. Let's get another image in. Let's see what the guiding is like. Okay. Ain't great. It's okay. We'll deal with it. I'm happy to get something. So, new stack. There we go. So, hundreds and hundreds of thousands of stars in here. And they orbit around the common center. And when 2 stars come close together, what can happen is they interact gravitationally. So one speeds up as it's catching up to a star. The other one loses energy and slows down. When that slows down, hi. Oh, yeah, you want that. When that slows down, falls closer into the center of the globular cluster. The one that speeds up is thrown out further into the halo of the globular cluster. And sometimes, if it gets enough energy, it will get thrown completely out of the globular. So it's gone. And we may be seeing some that are on their way out. We may be seeing a lot that are just in the halo. We don't know without seeing them for a long period of time. And at this distance, they're not moving fast enough that we can really tell. And while this is all going on, entire clusters orbiting the center of the Milky Way, or galaxy. So we see one here, and we see another one. Somewhere over here. Where was he? So many bugs. I'm not kidding. So many bugs. Bugs everywhere. Here's one. And this one is more distant. That's why it's dimmer. We can see a little bit of nebulosity through here. These are just live stacked. They're not processed. So it is still looking pretty decent. Okay. That's not bad at all. And this is basically 2 minutes of exposure. That's it. And we're seeing some pretty good detail in the stars. Just all through here. I wonder, is that a satellite track? Hard to tell without the next exposure coming in. That line that's right there, I don't remember if we were seeing that line earlier. It could just be an artifact. It could be a little line of stars. Kind of popped out, but there's another one. It could be an artifact. Well, maybe. Maybe not. Could be a satellite. I have seen satellites. I've seen lots of satellites ruin exposures. Oh, wow. So I'm hoping, yeah, you should be able to see this pretty well. Is that ants? Or something biting my feet. I'm wearing sandals, not socks. So it's fine. I'll probably survive. Right through here, we can see some of this nebulosity coming through. Not so much over here, but definitely nebulosity. Stay out of my drink. So many bugs. A lot of this cloudiness here. So later on when I do processing, hopefully I'll be able to pull some of this out and see what's going on. So we've done 3 minutes, 30 seconds of exposure to get this. That's not really a lot. Typically for something like this, I would do at least an hour's worth of exposure, an hour's worth of of images and then process those. So in this case, live stack, we're able to see a lot of detail. I'm pretty happy. This is a 30-second exposure at 350 gain, which is a little bit more than I really wanted to do. Typically for gain, I'll just do 100 when I'm doing my exposures, and that way, you think of gain as gain is basically like a noise multiplier. That's it. So you're multiplying pretty much everything. Sorry, dealing with another issue at the same time. Okay. Any questions about this? That Christian is asking to see M13. We'll swing it over there in just a minute. I want to get 5 minutes of exposure. Get 6 minutes of exposure. That way I have a little bit of data that I can play with later on. But, yep. So we've seen some galaxies. Now we see some globular clusters. I wanted to see some nebula. And let's just do M13. Let's see where M13 is in the sky first. So we're looking at this. And we're looking at M4. So let's look at M4. M4. Messier 4. There's Messier 4. And here's the other globular. And Antares is just off to the side, just out of the field of view. And this claims to be pointing over here, but it's not. So I'm going to do this. I'm going to resync this. Sync on M4. M4 is right in the middle. There's a little reflection nebula. No, that's not what I want. No, give me a hand. Cursor tool, just give me a bug constellation. Give me a hand. That's all I want. Just a hand. Here we go. So this whole region here has, oh wow, look. So there's dark nebula all through here. And this setup is not exactly great for this. I'd have to put on a different camera and run that one. Oof. So not ideal. But this is all dark nebula in the Milky Way. Then here's the Milky Way. So hey, here we go, Lagoon. Let's go looking at the Lagoon. This is M8, and this should look really, really nice. I may have to make a modification, but it should look fine. Let's do that. Let's do M8. So I'm going to stop this capture. Turn off this live stack. One more exposure. I'm only 7 seconds away, so might as well let it finish, right? Ooh. Isael is from Honduras? Cool. All right. So what do we got? One more. Oh, 14 seconds. Okay, cool. I'll let it finish. Last exposure, 9 seconds. And then we'll turn off, so we'll get 7 minutes, 8 minutes worth of exposure on this thing. It's not too bad. Okay. So when we did the Messier marathon, that gave 8 minutes of exposure per object, which is not a whole lot of time before jumping on to the next one. So let's go back to here. Messier 8, the Lagoon Nebula. So the Lagoon Nebula is a star-forming region. It is where stars are born. And it is a big cloud of hydrogen gas and hydrogen gas and oxygen gas and some sulfur. Let's do plate solve. Okay, give me a plate solvent annotation. Deep sky annotation. Where is everything? Here we go. So this is star cluster. M8. M8's all through here. All right, let's do this. Tools, and we're going to do a plate solvent resync, and that should recenter this. Hi, are you back? I know what you want. I don't have any food for you now. Come back later. Okay, I'm gonna offset. Are you happy? Are you happy? I think Doggo's pretty happy. Kind of stinky though. All right. As long as he's getting scritches, or she is a happy doggy. All right. Let's see what a 30-second exposure does. Nope. New stack. Clear. Okay. We're doing 15 more seconds for this one. Let's see what this looks like. Then we will auto stretch the histogram. Okay, I'm gonna need my other hand, you know. Gonna go off. Okay. Ooh, there we go. Okay, so we have a little bit of nebulosity there. All right, 30-second exposures. Let's see what happens. Oh, color balance. Bugs in my hair. Oh. "30 seconds may not be enough exposure for this." Ooh, not what we want to do. Not what we want to do, but that's okay. Oh, this is M4. We need to call this M8. Okay. Are we calling it M8? M8. Good. Okay. That's fine. 2 frames. Give it some more time. I think this needs a longer exposure, and also, he's not in focus at all, is he? Just start guiding again. Yeah, I am super not impressed with the guiding. That's okay. It says for 30 seconds. As soon as this one finishes, I'm going to set it for 1 minute with the exposure. When I was doing it earlier, I actually did 2-minute exposures. Let's try 1 minute first, and then see what we can get with 1 minute. So this cluster here is lighting up most of the nebula, and the nebula is going to be a lot bigger once we can actually see what's going on here. Let's see. Auto color balance. Yeah, let's do it this way. Auto color balance from the stars. And there we go. We can see a little bit more. And there we go. A little bit more, but let's see what a longer exposure does. Almost there. 3, 2, 1. Okay, a little bit brighter. There we go. Now we got something. Now we got something right there. Okay, so we're seeing additional nebulosity way out over here. Seeing more brightness in this area. Zoom in and see what we got. That's pretty decent. So many stars. We're already seeing some Bach globules, BOK. And what these guys are is they're clouds of dust. And inside is a star that is just being born. And it's either basically they're about to be born. When a star starts to fuse, it lets out a lot of radiation, and when it does, it pushes all that dust out. So the Bach globules are like these little hidden nurseries for stars. Um, it's they're really really cool, and they're just these dark blobs inside of these nebula, and we can see several of them. And if I had a longer exposure, if we took deeper images, it would be more easy to see them, especially post processing. But this isn't bad for live stacking. This is pretty good. Um, I'm pretty happy with this. If I go up, here's the star cluster that we talked about. That tends to, it's lighting up a lot of this. Um, all the red stuff, anything in red we see is the hydrogen gas that is being uh, fluoresced by the ultraviolet radiation from these bright, hot, young stars. Here we see an area, a lot fewer stars, and right next door, this is just lousy with stars, while this is pretty sparse. And the reason for it is, if we zoom out, these darker patches here, they're just dust clouds. They're dust clouds between us and the background stars. There are still stars there, but these stars are a lot closer to us than most of these. These are way further back. And these bands of dust all through here are blocking the light. Like right through here, we can see some of that too. So we think this dust is part of the same complex as the rest of the Lagoon Nebula, um, but it's not being lit up by the ultraviolet radiation. So the UV light doesn't go past a certain point apparently. Um, it's blocked by a lot of that dust, and so when the dust blocks it, any hydrogen gas past there doesn't get lit up. And then if it's just dust, it doesn't get lit up either. If there were stars here that were causing like a reflection onto it, if they were close enough to be reflecting off of it, then that would be one thing. But we don't see that here. We just see hydrogen being lit up, and then areas of dust where nothing is happening. It's blocking light from behind. Now, again, if we're using James Webb or another infrared telescope, we could pierce that dust and see what's beyond it. We could see a whole lot of stars, and we've actually done this with like the Horsehead Nebula. The Horsehead is it's a dark nebula in Orion. Looks like a horse's head, and um, it is a cloud of dust. It's blocking the light from behind. And with visual telescopes, we can't see it, but James Webb is infrared, and we can see right through it. We can see the stars in and beyond the Horsehead Nebula. So this is getting brighter and brighter. That is nice. We have a 7-minute 7-minute total exposure time. That's pretty good. That is not bad at all. What do you think? So M8. This is the Lagoon Nebula. Two. Okay. That looks pretty cool. That's pretty cool. All right. So I'm going to do this. I'm going to leave this. I'm just going to let this thing go. And I'm going to go get another scope ready. It's 11:13. You can watch this for a little bit longer. I'll zoom in. So it's a little bit nicer of a view, better of a view, closer of a view, I guess. Um, that is a pretty cool view right there. So many stars. Remember, we're looking into the Milky Way. This is deep in the Milky Way. What I really want to do is get one of these cameras up. Let me do this. I want to plug in one of the TV cameras that I have. It's got a really wide lens on it, and I'm going to see if we can see what's going on. Like, I want to see if we can replicate with the camera the kind of Milky Way that we can see here. I don't know if it's possible, but I want to try it. So while this thing is going and the bugs are crawling all over my screens. Okay. All right. I need a light, and I need a HDMI cable, and I need power. Maybe. 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 Not ideal, but I'm trying to make it work right. All right. Okay. There you go. Ready? Yes. Second. Yep. Fourth. Wide open. And Tokyo. And don't think I have the right. Think I don't. What? Oh yeah. Anyway, does it? Okay. No idea how this is gonna work. Bring it up. Put it back. Trip on anything. Trip on anything. Don't trip on anything. Okay. So. All right. That's pretty good right there. That's pretty good. Okay. So I'm going to see. No, wait, I can't do that. I need to go get a cable. I forgot to do that. Let me grab a HDMI cable and see if I can get this thing to work. Here is again. I have no idea if this is going to work. This up here. Always stuff to do. There we go. Again, I have no idea if this is going to work. We're going to bring up, let's see. Oh, I have no idea. Let's just see what happens. Video capture. Okay. Big new. Let's try this. Okay. Okay. Right. There is something. Okay. Here we go. Yeah. This is what I'm seeing. Let's see if we can boost this. Let's give it some filters. I need a gain. No. Yep. Where's gain we can do? Nope. Nope. This isn't going to work. Need an effect filter. No, that's not going to work either. So it have to be gain. Noise gate, video delay. No. There we go. Let's do color correction. Camera. Whoa. Not quite right. Brightness. Nah. How much brighter can we make it? Nope. I don't think this is going to work. I don't think the camera is sensitive enough to see it. Yeah, what I'm trying to do, you can see a couple stars near here. Scorpio. Here's the head of Scorpio. Here's Antares. This is, and we're actually looking out over here. Here's Sagittarius. But yeah, this isn't that great. The sensor is just not great for seeing this dark. It's unfortunate too. I was hoping you could see a little bit more. I've got the gain turned up as much as I can with the contrast. Yeah. Oh, maybe. There we go. Now we can see some stuff. Not seeing the Milky Way. Bring that down. Let's see what this color multiplier. No. No. Okay. It's not too bad. No, I don't think we have. No, I don't need that. Nope, that. I'm adding some filters onto here. I have not done before. Let's do sharpness. No, that doesn't help. No, not that much. Okay. That's as good as I can get it. So we're looking at Scorpio right here. Here's the head of Scorpio, Antares, and the tail comes down like that. And the Milky Way is right through here, coming up. So here's Sagittarius. And where we see Sagittarius, we're looking at the heart, or the core of the Milky Way. That's my car. The top of it. Now what I'm going to try to do, see, going fast, but I can get the focus. Focus that way. Let's see, can we focus? Nope. Do it the other way. What I can do, let's see if we can zoom in a little bit. The focus working? I can't tell if the focus is working or not. I don't know. I'm gonna go over there and see if I can get the focus to work. Nope. No. I don't think I have anything. But we can see Scorpio. It's kind of hard to do this. Yeah. Out of focus. Okay. Okay. My focuser doesn't seem to want to work. Try it again. Nope. I think it's not connected. Nope. Doesn't want to work. Okay. There we go. Now we're back into fairly decent focus. Okay. I don't think this is much of a success, do you? You can see Antares, it's red. There's Sagittarius, looks like a teapot. Here's the lid. Here's the spout. Here's the handle. And when we're looking at Sagittarius, this is at the center of the galaxy. But yeah, you can't really see very much. Looking at M4, M4 is right here. Oh, you can't see that. Okay. Yeah. You can't see that. That's okay. I wish there was a way I can annotate it. Nope, I really don't have a way to annotate that. How about this thing? No. Nope, I don't. In the middle, lower, just past the middle, there's a bright reddish star. That will be Antares. So, yeah, can't really see very much on there. That's okay. I'm going to switch it back to here. We can see it's gotten brighter and brighter. We've done a 23-minute exposure already on this thing. Let's see what we can see. That's pretty good. That's really pretty. Now we can actually see some of the additional dark nebula all through here, all through here, all through here, all through here. But we've got 23 minutes of exposure, about to be 24 minutes of exposure. That is not bad at all. What do you think? Good image? And remember, this is from a dark sky site, so it's going to be better here than it will be in the city. I don't have to have any filters on here. I'm just imaging. So pretty good. I'm going to go ahead and turn off this light. I don't think it matters much. I'm not going to be too red. Still see me fairly decently here. So this is quite nice. I'm pretty happy with this one. All right. Doggo's coming back. All right, I'm going to stop this live stack, and we're going to move up in the Milky Way. I'm going to move up to Messier. Oh, what is it? Messier 16? What is it? Let's find out. I think it's Messier 16 I want to go to next. The Eagle Nebula. It is just, actually, no, Trifid. Let's do the Trifid first. That's M20. It's close by. M20. Go ahead and slew. So we're right here. We're just going just a little bit up to the Trifid. Let's see what the Trifid looks like. And I like the Trifid because there's a reflection nebula, and there is a there's a reflection nebula, and then there is the emission nebula. It's called a Trifid because this looks like it's separating out into 3 different petals. Just do sync. No, just center it. Keep it in the field of view. Come back here. We're going to do stop. Pick a star. Good. Keep guiding on that one. Clear it. Yeah, my guiding is absolutely horrible, but I'm not terribly concerned right now. So we're going to go M20, M20, and do a live stack. Clear it. First, before we do that, I'm going to do a short exposure. Let's do 15 seconds. Okay. There we go. That's it right there. That's the Trifid. So we see the reflection part, and we see the emission part. 1, 2, 3. Looks like 3 different petals, so it's called the Trifid. Cool. All right, let's get deeper. It's only 15 seconds. Let's go full 60. Start stacking this thing. So zoom in. Oh, and when we zoom back out, Lagoon's over here. And this is yet another cluster over there. Let's zoom in on it. Ooh, too much. Back off just a tad. There we go. Lots of stars. Pretty round. Pretty happy with this. This is only 39 seconds of exposure. Getting some bigger bugs now. So here, the dark places, these are dust bands. So they're basically clouds of dust which are blocking the light from the nebula behind. And we have a little bow. I don't think this is an exact bow shock. I don't remember. But there's a little region here which is being lit up by the stars here in the middle, and it's blocking the light behind. So this looks a little bit darker than the lit up area right there. Excuse me. And this part here, these the bluish part, this is a reflection nebula. So it's dust that's just reflecting the light from the stars here. Maybe this one star. Just more dust bands all through here. This is a pretty good image. Especially at 99 seconds of exposure. Getting brighter. Getting brighter, we're resolving more details, we're seeing more stars. And that's kind of the important thing, is we're seeing more stars. Wow. Pretty happy with this. It's actually pretty cool. Well, let me know what you think. Sometimes it's just nice just to stare at it. Another image coming in. A little bit brighter. Tracking is, I'm not impressed with the tracking. It's fine. This is good enough. Good enough for us. When we can resolve stars down this small, it's fine. It really is. Not terribly worried. Now on the other one, yeah, well, hopefully we'll have better luck on that one. Okay, so here's what I'm going to do. While this thing is gathering some data, I'm going to do a polar alignment on the other scope. Let's just see if we can get that one working. I don't think I'm going to be able to get the third scope up. I don't think it's necessary. We're doing some nice wide field stuff with this. But yeah, I'm going to see if I can get the other one up. Maybe we can get in some really close-in views on some of this stuff. All right, so I'm going to go on the other end. That is looking nicer and nicer, isn't it? Okay. All right. I see Naz is on from the northeast from Boston right now. Um, we are in our dark sky site. So for everyone new showing up, we're in the rising star observing area for the Fort Worth Astronomical Society. We're in a Bortle 2 sky. And right now we're using a C11 with the hyperstar to look at the Trifid Nebula. Oh, wow. So we can see more of the lagoon right here. We were just imaging the lagoon a little while ago, or just before now. Now we're got 9 minutes, almost 10 minutes on the Trifid. And again, here, we're seeing the same kind of thing that we were seeing with the lagoon, where there are these patches where there are fewer stars all through here. And the reason why there are fewer stars is because there are dust bands that are blocking the stars behind. So when there's no dust, we can look deep into the Milky Way and just see thousands and thousands of stars. Let's go ahead and do that. There's a Trifid. Oof. So many bugs. And as we're looking through, every one of these dots is a star. Right here, that's dust. That's blocking the light and the stars in the background. And there's a lot of this dust closer into the Milky Way. So that's really nice. It's a lovely color. The blue color is coming out from the reflection nebula, and the reddish color is coming out from the emission nebula. And if I had filters on here, specifically if I had if we're doing black and white photography with hydrogen alpha and sulfur 2 and oxygen 3 filters, we'll be able to isolate specific elements that are in this area. So we could see the hydrogen, we could see sulfur, we can see if there's any oxygen there. There's probably is some, but this here is the reflection side. Oh, excuse me. It is 11:44 p.m. We're going to keep going till we can't go anymore. So the lagoon is over here. This is the Trifid. We think it's all part of the same complex, that there's just a lot of gas and dust through here. But this is being lit up by the stars here. This is being lit up by the stars here. And there really aren't any in between to light up the gas and dust that's in this area. Don't know for sure if that is the case. But I got 12 minutes. Okay. I'm going to see now on the other side if I can do, what am I looking for? Do the polar alignment. Again, we've been sitting here since, basically since 10 o'clock, almost the last 2 hours, on one scope, and I want to get a second scope up. So I have a, here we go. Okay. I have another C11, but this one is set up with just a 6.3 focal reducer, so we have a much narrower field of view. There we go. No. Okay, I'm going to play it. Double click on it. Okay. Yeah. So I'm going to have to go back to the mount and move it. Yep. So let me go do that. Let me deal with it. Where's my light? I don't know where my light went. I left it over there. On the ground. Of course I did. Okay. I'm going to start processing. Get this one ready. And then we'll do that. So let's watch this thing a little bit more before I get the rest done. maybe it is. Yep, that could be right. We're looking at the Trifid right now. We're looking at the Trifid. Want to come see? Oh, yeah. Okay, I will move down. You want to sit down and introduce yourself? Oh. Sure.
Howdy. I'm Peter Tijerina, member of Fort Worth Astronomical Society.
So here's what I'm going to do. I got to get Polaris down to here.
Okay.
Okay. So tell me when I get. Tell me if I'm moving in the right direction.
All right.
Move down.
Moving to the left.
Is that the right direction?
No, it is. Generally, you need to move down and left. Yeah, now you're coming the right direction. Almost there. Keep going.
Oh.
Need to go to the left a little bit more. All right, you're about down far enough.
Set up ranging out.
Bingo. Oh, well, maybe just a wee bit more. To the left. Right there. Well, it keeps springing to the back to the right again. Okay, I think that's it. You're right in there. Awesome.
Almost midnight. I'm just getting the second scope up. I don't think I'll bother with the third scope tonight. But this is looking pretty good.
That's looking really nice.
All right, let's get this laptop into place. Close. Okay. Connect the cameras. Rescan for camera. Uh-oh. Oh no. I think I unplugged something. Excuse me. Okay. I don't know how well this is going to work, but we'll try it out. So we scan cameras. It's not picking up the camera that it was just picking up. Unless there's a... Is there a driver issue? Oh, don't tell me there's a driver issue. I have to look at what I was seeing. I was seeing it. Well, that's not good. That's not good at all. Oh, I wonder if I'm missing something. Okay. I'm checking to see if there are any drivers that I'm missing. Sensor, blah, blah, blah. What I'm looking at, this is the camera that I haven't used before. I'm borrowing it from one of our club members. Ooh, software. Okay. All right. Yeah. Well, now I need to go find a disk or a spare drive. I just had. Ooh, here's one. Excellent. Okay. And it's got one of those plugs, so on there. Okay. Now we just do it on here. Yep. I'm gonna do it on here. Of course we are. I think I already downloaded these drivers. All right. See, downloads. iOptron. Yes. Camera direct show. SI driver setup. Yep. Let's just do these. Okay. Nope. That's the one I want right there. We're going to. There we go. Bugs. So many bugs. Bugs absolutely everywhere. But that's one of the prices that we pay. Okay, that's not what I need. That's what I need. Yep, doing this live. Yes. There we go. There we go. Next, I can pull this out and find the port. Somewhere over here. It was over here. Okay. On this side. Oh. Where is it on this side? There it is. I'm just trying to find the USB-C port. There it is. Nicely hidden away. Okay. I don't think I have the right drivers installed on here. So it's just a matter of installing the right drivers. Once everything's installed, I think we'll be able to see the camera. This machine. Yes. I think this is it. All right. Yes. Install. Let's see what's going on. Okay, so we've been imaging this thing for 25 minutes. I think that's plenty of time. Let's go ahead and stop it. I'm going to stop the live stack. That looks pretty good. And now we're going to move off to, let's see, bring this up. Where are we going to go? We've been here looking at the Trifid. It's really pretty. But now it's time to go up to the Queen, the Eagle Nebula. Let's see how well this works. This is M16. I can actually control it from here. And 16, let's see, I'll just do a confirm slew. We can say that. See where this is, where it says it is. Okay. All right, so we have a, let's do a quick exposure. We'll do a 4-second exposure. See what we're looking at. Okay, I think we're looking at the right region. Plate solve and resync. Okay. Almost there, and we'll do a deep sky annotation. Eagle Nebula, the Star Queen. Okay, let's do Eagle Nebula and do center in view. We'll fix that. Come back to PhD. We'll do stop, restart, pick a star. This is not focused at all. Maybe one reason why we're having such bad guiding. Okay. But it's fine. So we got the eagle. Let's do, again, 60-second exposures. So many bugs. Eagle. Live stack. No, clear. All right. Got 45 seconds. And in the meantime, I'm getting the other machine up and running. Close this. Close. Okay. And where do we have so many icons? And do this. Sharp cap. See if this works. Okay. Hey, here we go. That's not bad for a minute of exposure. And the Eagle Nebula is, we have the famous Pillars of Creation from Hubble. Yeah, it looks like our guiding's a little bit off. These right here, here's the head of the eagle and claws coming up and the wings all around. So these are the Pillars of Creation from Hubble. And I don't have internet access on this laptop because I didn't bother plugging it in. So we also have a rather secure network here. So only computers that are allowed to get in can get in. Oh, good. Here we go. Okay. Ignore that error. Okay, okay. All right. Ignore that error. Okay, I'm getting everything up and running. So I have to go sharp cap settings on here. Pick my hardware. Celestron is that. It's not a ZW focuser. It is a Celestron focuser. Yes. No filter wheel. Good. All right, let's get this thing up and running. Let's do a 4-second exposure. 200 gain. And what am I looking at? Nothing. Okay. Interesting. Okay. Okay. I'm trying to get this other machine up and running. Okay. One more. Maybe. Maybe? Okay. But my focus on this thing is probably way off. Yep, it is off. If I can get this thing. I need controls that go on. Okay. All right, so while the eagle is going, and getting prettier and prettier and prettier, go look at something ugly. That. What do I see? I see a little bit of something right there. I don't know if it's visible, but let's get this thing going. Okay. I need longer exposure. I need 8 seconds. Even with this stupid game. I see something, but I'm pretty sure my stars are out of focus. Greatly out of focus. There we go. See that? That is an out of focus star with a Batinov mask. Let's fix that. Okay. That's my focuser. I can't tell which direction that's in. What? Fine. We need to be faster. Here we go. This is the nice thing about having motorized focusers is you can do stuff like this remotely. Wrong direction. Go in the opposite direction. Wait till it comes in. One more, probably 2 more. A Batinov mask is well, it looks a lot like what the star looks like. It has slats in it that are angled, and when they're angled this way, it lets me do something really cool and get a good focus. Right there on this guy. Let's zoom in on him. Ooh, how noisy. Okay. Somewhere there-ish. There we go. So now, what I should be able to do, come in yet again. What I'm looking for is spikes. I want to see spikes. Okay. Yep, wrong direction. Go back one. What the spikes are doing, this is a quantum mechanical effect. And what I'm trying to do is get it to be spiky. And let's, gotta get my exposures down to probably 1 second. Okay. Now I'll be able to see this a little bit better. So let's get, I want to get that as small as possible. And what we'll see is, oh, now it's getting bigger. Wrong direction. Going the wrong direction. Let's fix that. And I want to get as small as possible. And what I want to see is 3 lines going right through the middle, and I want them symmetrical. Okay. Go. We're almost there. Come on. Almost. There we go. Okay, that's almost there. What I want is a little bit more. That's pretty good right there. That's pretty good for symmetry. And the way you can tell now is I will take a slightly longer exposure. Go 4 seconds. And way out. There we go. These lines right there. We want these to be as symmetrical as possible. Bugs all over my screen. That's pretty close. I'm going to call that good enough. Okay. Now I can take the mask off. When I take the Batinov mask off, now I won't see those spikes anymore. I'll just see a single star. Yeah. One fat nose mask is off. And now we have nice round stars. Roundish. Close to round as we're going to get right now. So if I do this, oops. What we're probably doing is looking at Polaris. That's probably Polaris right there. So we're looking at the North Pole. Now it's a matter of figuring out where we are. So let's do this. Tools. We're going to do plate solve. Capturing the frame. Figure out where we are. Go to my settings for plate solving. Do I have any other plate solvers I installed? No, that's all I got. You boy. Well, I have some on this machine. There's one machine over here, and there's the other machine right here. So at least there's that. Okay. Now it knows where we are. Cool. What if I do Starry Night Pro? Connect to it. Let's jump back to this. See what that looks like. So we don't have great guiding. Those are ugly, ugly stars. But if I zoom out, it's not that visible. And we can see the Eagle Nebula. And it extends out a long ways, not just the core here. It's extending out past here, even down to here. Here's a part of the nebula, and there's dark nebula through here. So it is fairly large. And by the way, the full moon is about that big or so on the screen. So this is fairly large. The lagoon is fairly large. I think the lagoon takes up, I think it's like 3 full moons across and 2 full moons up and down just for that central region. On. So now we've got 10 minutes on this. Guiding isn't great. I'm not really happy. Oh, that's so ugly. That is so ugly right there. Let's just stop the guiding. Oh, that's horrible. Okay, let's go look back at the Milky Way and see what we got. What else can we look at? M13 was requested, but here's the Milky Way. So we're looking all through here. What about your series? That's not going to be... What is interesting all through here? We have another satellite coming out. ESAT. Down to the core of the Milky Way. Scorpius here. There's some nebula right there. What if we go up? Let's look at something up here. Altair. Oh, I know what we can do. Let's go into Cygnus. I haven't done anything near the Seda region. Here's a supernova remnant. Okay. I don't think we'll be able to fit that whole thing in, but let's do this. Let's do North American. I imaged this a couple weeks ago. Let's see just what we can do to the North American. In the meantime, I will stop this. Yeah. Turn off that live stack. Okay. All right. And let's figure out where we are. Next frame. Okay. Connect. Scope setup. Figure. Electron. Okay. I'm I'm looking at the other monitor now. I'm trying to get this thing. Okay, here we go. Connected. Unpark failed. Full alignment must be done. No. All right. Let's do this guy. I'm going to do a full. Yeah, here we go. God. I don't think this is. Yeah, I don't think this is going to work. My focus isn't good. Focus is not good. But I try to figure out what it's doing on that one. Okay, in the meantime, jumping back over to this guy, it's telling me that I can't connect the scope. I have to do an alignment. So I'm going to jump over to that one. Maybe we can get a couple of hours in on that scope. But what I want to do is dim stuff, small stuff. I want to see the ring nebula. But to do that, we need a little bit more power. So let's do that. I think I did actually a horrible, horrible, horrible ugh, alignment. But let's see if it'll let me connect. Good, now it's connected. Okay. Okay, it thinks it's pointed at Antares. I don't think it is. What the details are on here. Ugh. Yeah, calibration for this thing is just horrid. Let's see what this looks like. So we're looking at North American. Yeah, let's do live stack on the North American. Do clear. NGC 7000. Okay, see what that looks like. And in the meantime, on here, yeah, I'm not sure what we're looking at. Antares. Okay, well, there's Antares. Okay, so we're close. But man, it's streaky. There it goes. Okay, so let's do tools. I'm actually I'm pretty impressed I got this close. I really am. Eesh. Okay, let's do resync. Plate solve and resync. That's okay. Cool. Cool, cool. All right, go recenter. The only thing I don't like about Celestrons is it pulls it out and then sticks it back in. Okay, I don't think I'm looking at NGC 7000. This is a North American? I don't like that star there. That's a funky star. Oops, I'm looking at the wrong one. There's Antares, so this is supposed to be North American Nebula. I don't think I'm looking at the right place. Let's do this. I'm going to go back to a 1 second exposure. Oh, so many bugs, giant bugs, huge bugs. All right, I'm going to do, should have done this before. Let's do plate solve. Fine. Give me a plate solve. Turn off the live stack then. And let's do a annotation. Deep sky annotation. This tells me what we're pointed at. Objects nearby. There we go. That's what I want. North American, and it is load the image, center in the view. Yes, I would like to center this in the view. Okay, here we go. Now we'll be good. Now we can do a live stack and set this thing for yes. And set it for 60 seconds. And clear it. So let's see what this looks like in 60 seconds. In the meantime, jumping over to the other one, looking at Antares. This is the blood red heart of Scorpio. Is a red supergiant star. So it's going to explode. And now we have this. Okay, cool. What can we look at? We can look at the Trifid. Let's do this. Okay, view, labels, show everything. I'll see what the Trifid looks like a lot closer. Okay, come on. That's one thing I hate about this. This one doesn't do. Okay. All right, here we go. M20, fine. Slew to here. It's working. Say 4 second exposure. Uh-oh. Clear this. Oh, that is horrible. Clear. Stop. Died. Okay, give North American messed up. I had to restart it completely. That's fine. It's doing its thing. And the other side, it's doing its thing as well. Please no bugs. Please no bugs. No bugs. All right, we got something. Let's check where we are. A deep sky annotation. Two just out of view. Cool. Hmm. Okay. How about this? Tools. Plate solve and resync. Now this will tell the mount this is what you're actually pointed at. Now it's moving. But this one's got pretty colors to the stars at least. Yeah. Not happy about this. There we go. There's a Trifid. M21 objects in view. Let's center this. Center this in view, please. Yeah, the Celestrons move out and then they come back in. The Ioptron mounts, they just move directly to it. I prefer the mounts that move directly to an object. Here we go. So we can see the hydrogen alpha. And just barely there. And this is a 4-second exposure too. All right, let's do this. Turn the gain way down and do a 60-second exposure. Let's see what we see. Then I should probably get PhD running. PhD P8D2. Do a live stack. Okay. And I think we did this one and okay. Yes. We need to do this on the first image that comes in. Okay. Oh. Hey, here's part of the North American. While that thing is loading, come back to North American Nebula. We're seeing something. So here's the Cygnus wall right here. Again, this is 60-second exposure. So once it's only been 2 minutes, once we get a couple more exposures in here, this will brighten up. We'll be able to see more detail. And again, we can see these dark patches. These dark patches, again, these are dark nebula. They're dust bands. Let's see, and where is the Cygnus wall? Call that because it looks like a wall. One side is lit up, the other side is dark. We have these black bands right here, these black dust lanes. So we're getting better and better. The green pixels, any bright green pixels you see like this one here, they're just hot pixels. It means that it's constantly thinking that it's getting a signal, so it goes super green and that's it. So you see red ones, blue ones, and green ones. So here's one green one, here's another green one. And we typically just process these out in post-processing, so it doesn't matter. Okay, I'm still not seeing anything. I'm waiting for the next exposure to come in. Okay. Let's see which camera. That one. Connect. Mount. Celestron. Connect. And close. Okay. All right. Let's go with calibration. calibrate here. Yep. Nothing? That's not right. Okay. Not good. No, we're not seeing. Make a 60-second exposure. No, I should have plenty of gain. Yeah, I'm not sure what's going on. Okay, we're waiting that thing. The Cygnus wall is at least coming in. Oh, you can see that there's a little bit of trailing, and that's fine. Stacking cleans it up. And if we had a lot more exposure time, if I took this up to several minutes, we would see a lot of red all through here. And the reason why it's called the North American Nebula is it resembles North America roughly, except that it's hard to see from here. Yeah. Excuse me. 12:30. Okay. But we are able to see at least this. Okay. I'm going to give this just a few minutes, and then we'll jump over and do something else. We'll look at some clusters. We'll look at the Ring Nebula. I want to bring up the Ring Nebula. I'm trying to see why I'm not seeing the Ring Nebula right now. Yeah, something about my live stack on here isn't working. Let's see. Let's get the guiding good. Okay, good. Guiding should be good. Do this. Come on. Okay. All right. The dogs are barking at something. Okay. I'm going to wait 1 minute for the Trifid to look better. And then we'll jump over and look at that. Right now, it's still going. We'll have 40 seconds on the Trifid. While this is getting nicer and nicer, but it's still hard to see. This is actually, I think this is the Pelican Nebula over here. Don't remember exactly. Let's see, was it annotation? Deep sky annotation. This is not right. Do plate solve. There we go. So this is the Pelican Nebula over here. Open cluster. Yeah. Okay. All right. Here is a zoomed in version of the Trifid. I'm going to do a light stack on this guy. Okay. See what settings I have on here. Align. Oh. Brightness filter. Raw frame, save non-stack, sigma clipping. Stacking, we'll do sigma clipping. Okay. What else do we need? Okay. Well, okay, over on this side. I'm comparing the two histogram stretches. Right. There we go. Okay, cool. Got our first image. And it will get brighter. It'll get significantly brighter as we get longer and longer exposure. But this is a nice zoomed in view of the Trifid that we were seeing earlier. So this isn't bad at all. We'll let that image for a bit. Next target on the other one. Talk about Messier 13, another globular cluster. We can jump on that one. If anyone has any requests, go ahead and just put them in the chat. I am watching it. So, here we go. What are we looking at? Should be, yeah, we're looking right there. It should be on here. That's fine. Let's see. Function. Okay. There we go. Okay, and we're looking at what on here? Where are we gonna go? Vega. No. Let's do M13. M13. Okay. Other side of the sky. Okay. From blue. It's gonna move way over. Stop that. Loop again. Okay. 12:35. Again, if there's anything specific you want to take a look at, let me know. We're on a dark sky site, so we can even look at galaxies if they are up. I want to do that, so that thing is going. So this thing is, ugh. Go back to the Trifid, we can stay on there while I figure out on here where we're looking at. Oh yeah, live stack. Turn that off. Okay, so now we're going to go Tools and Plate Solve on here. Where are we? You know what I really hate? I hate it when I'm trying to click on something on the touchpad and a bug gets directly under my finger as I'm trying to click on it. Right, what we're looking at? We're looking at M13, right? M13. Center in the view. Next image coming in, 60 seconds. That's that. Maybe 2 seconds. There we go. Okay. 2-second exposure. We need more than that. Go 30 seconds. See what happens. 1 30-second exposure. I swear I'm going to come home with so many bugs in my equipment. I don't know if y'all can hear, but there are a lot of crickets. Pretty sure. Here we go. Can you hear the crickets? They're rather loud, so I will turn on noise reduction so you don't have to listen to crickets like I do. Unless you like the ambiance. Here we go. M13. Turn off this. No, I don't think this is going to be much. Ooh. Clear. Here's M13 in the guide scope. I think I need to recalibrate different part of the sky now. My stars just are not very good right now. Ugh. But the Trifid is looking nicer. Only a 5-minute exposure on the Trifid. That is not too ugly. That's not too ugly at all. The stars look like they're a little bit streaky, not quite round. And I'm pretty sure it's because, yeah. I have a little bit of wind that's going to make you shake. Yep. Ooh, now the wind is coming in. So it's going to make everything shake. You can see that right there. Wow. Really obvious. But it is what it is. You just deal with it. And hope for better frames. Hoping the audio is coming in well. Right now there's lots of dead air. It's only because I have the noise suppression down so you can't hear all of the crickets in the background. Oof, not here. The wide field. Okay, let's just do live stack, see what happens. What is that sound? It's a weird sound, but okay. Clear. Stack, almost there. There we go. And there's the A13. So this is another globular cluster. This is the Great Globular Cluster in Hercules, or the Hercules cluster. And it is another globular like M4 that we saw at the beginning of the night. Again, these are thousands and thousands and hundreds of thousands of stars in one big ball, all orbiting a common center of mass, and with the faster stars thrown off into longer, wider orbits, and the slower stars with less energy condensing down to the core. So we call this evaporation, where the faster, when you have gravitational interactions between two stars, one star speeds up, the other star slows down. Either the one coming up to a star from behind, that one will speed up in a gravitational slingshot, and the star that was passed will slow down just a little bit. But when you have enough of these interactions between stars, the ones that slow down are losing energy. They're just falling closer into the middle. The ones that gain energy are either flung to the outside halo or they're flung completely out. And so over time, any large group of stars, of this number, hundreds of thousands of stars, are going to form a globular cluster. And they're going to look roughly like this. And we have larger ones, we have small ones. We have some with like a couple million stars, and we have some that are just tens of thousands of stars. But they all follow the same kind of rules, where you have a denser core and then a less dense halo. And towards the core, you may have, well, on the average, I think we have, in our part of the galaxy, we have one star every 10 cubic light years. There, you may have 100 stars in a single, in that same 10 cubic light year volume. So they're very, very close together. There's so much radiation. Life is very, very unlikely in the core of a globular cluster. The thing is, the stars in the halo, they're not constantly out in the halo. They come in to the center as well, and then they get thrown out. When they gain energy, they go further and further out. But they're gaining energy in the core. They're not gaining energy when they're on the outside. So if you ever play a game called Kerbal Space Program, you will learn about orbital mechanics very, very quickly. You will learn that the closer you are to a body like the Earth, the faster your orbit has to be to prevent you from, well, hitting the ground. The further out you are, the slower your orbit can be. And if it's too fast, you throw yourself out of orbit. If it's too slow, you'll still fall down into the gravity well and deeper in the gravity well and possibly hit the planet. We learned very quickly that when it comes to space, the faster you go, the slower you go. It means if you speed up, you go into a higher orbit, you slow down. And when you slow down, you're actually going, well, let's see. Yeah, if you speed up, you slow down. If you slow down, you speed up. So if you're in a high orbit and you slow down, you actually fall down closer to the planet and speed up again before being thrown back out, slowing down. So it's all a matter of energy, and that's what we see in globular clusters like this. They're very, very pretty. And when you're looking through a telescope, like one of the larger Dobbs that we have down that away on the end of the concrete pads, they look like a basket of jewels. They're absolutely gorgeous. And also, all these dots around here, those are stars too. Those are stars in the globular cluster. They're just smaller. They're not as big. It's not as bright. It is 12:45 a.m. There's still some stuff I want to look at. So if we go to the Trifid, considering I just got this scope up and running, the Trifid is looking very nice. I think I could go for longer exposure and it would make it brighter. We'd also risk some more star streaking, so I don't want to mess with it too much. But that looks pretty good for 10 minutes worth of exposure. That's not looking too bad. So I'm okay with this. We can see what I kind of wanted to see with it, where we see the nebulosity, the reflection nebula, and then we see the emission nebula. We saw it much brighter in the other image, but that's because it's a much faster scope. And on here, it is a much slower scope, but it's zoomed in more, so we can see finer details. So I like this one. This one's fine. I'm going to swing this onto the M45, the Ring Nebula. I want to see that. In the meantime, while I'm getting that, look at M13 again. This is just really, really pretty. Again, you look at all these little dots all through here. These are stars. All through here are stars. They're very, very faint. They're all there. And we can resolve pretty much down to the core. Let's do that. We're resolving stars in the core down here. So that's pretty good. I think my focus is just slightly off. Not a huge deal, it's just slightly off. Oh, there's a galaxy. Look at that galaxy. Hey, it's a little spiral right there. Hey, is that neat? That's pretty cool. A little bitty spiral. I'm not sure if that's a star or if that's supposed to be the core of the galaxy. I don't know. Can't tell from here. The way I would tell is I would put on a different camera and I would put on a spectrum filter and try to get the spectrum of that core. But it would be kind of hard because there's a lot of light coming from the galaxy itself, so like I might be picking out that instead. Okay, so I'm gonna drop the live stack on here. I'll bring this up. We're gonna go to Messier 45 and 45 on either side. No, not M45, M47. Sorry, M47. No, what's the ring? M42. No. Orion. M40 what? M48? I don't remember. Nope, let's do ring. Ringtail galaxies, Ring Nebula. Alright. Ring Nebula. M57. No one corrected me. M57. Okay. And let's do. I need to do like a 4-second exposure again, so we can make sure that looks good. But that's a galaxy here. I think there are a couple of other galaxies through here as well, but they're also faint. I think we need longer exposures to make sure they look fine. But, almost 12:49, almost 1 a.m. So tell me, do you want me to keep going, or do you want to call it a night? So I can start at least packing up something. Oh, here we go. Do tools, plate solve. Here we got. Am I looking at the right place? Am I looking at the right place? No, I was not in the right place. Yep, offset of 1.24 degrees, and the field of view here is so small that I wouldn't be able to have found it. Okay. Let's see, tools. Deep sky annotation. The Ring Nebula. Ooh, a little galaxy behind it. Okay, cool. Let's do it. So I've got a 4-second exposure. We're gonna have to go 60 seconds at least. And light back. Clear it. Here. Okay. Stop. I can tell you this. PhD was not designed for what I'm doing with it. Trying to do a star party. Let's see what it does on there. Hopefully it'll be fine. New stack. Almost there. 25 seconds left. In the meantime, I need to think. Where did I put? Oh, there we go. Have my little red light. My big red light. Oh, there's my thermos. Okay. I will drink this off camera because it probably does not look great. First. Here we go. One Ring Nebula. Alright. I'm going to clear it because I want to see what my guiding is like. Yeah, guiding will be better in just a moment. Let's check it out. Not quite centered. Honestly, it's fine. Watch it come in. Another 20 seconds. Okay. Ah. Any moment. Nope. Alright, that's not great. What am I looking at? What are we looking at? There it is. There's the ring. Okay. Let's zoom in on this. Let's do that. Alright, that's too much. 50% would be fine. And over and up. There we go. There's the Ring Nebula. So the Ring Nebula is a planetary nebula. We typically have a couple different nebula. We have Emission Nebula, which we've been seeing the whole night. Stuff like the Eagle Nebula, the Rosette. These are regions of hydrogen gas where there's a group of stars that's exciting the gas, making it fluoresce, making it glow. They're typically places where stars are born. We have dark nebula, which we've seen, and these are bands of dust and gas that isn't being lit up by any stars. We have reflection nebula, which we saw in the Trifid, which is dust that is being lit up by a star. It's not fluorescing, the light is just reflecting from the dust. Here we have a planetary nebula. A planetary nebula instead is the remnants of a dead star, or at least a dying star. And what's happening here is right in the middle, there's a white dwarf right there at the center. This is the core of a much larger star. It could be a star about the size of our sun. And what we're seeing here is the reddish part on the outside is hydrogen gas. As the star dies, it blows off its outer layers. What happens is it stops fusing it stops fusing hydrogen, and then you have a collapse. A star is basically a balance between the outward pressure from fusion from the core and the inward pressure of gravity from all the mass in the location. So when it stops fusing hydrogen, it loses energy, and that outward pressure no longer exists. So it collapses. When it collapses, the pressure goes up high enough and the temperature goes up high enough that helium starts to fuse. When it does, it releases a lot of energy, a lot more than hydrogen. What happens then? It causes a push outward. Remember, there's more energy, so it pushes outward against gravity. The outer layers get blown off out into space, just pushes them all out. So what we're seeing here is these outer layers have been blown out, and that's hydrogen that's been blown out from the red. You can see that. Once the helium starts to run out, it collapses again. You have the same thing happen. Gravity wins for a little bit, the pressure becomes high enough for other elements. So helium will then fuse into lithium and beryllium and other elements, oxygen, nitrogen, things like that. And so we have this formation of new elements in the cores of stars. When that runs out, or when the lithium runs out, you have another collapse. Oxygen starts to fuse. We have additional fusion processes, and additional layers get blown out. And finally, by the end, the only thing that's left is the hot core of the star. Sorry, there are coyote that are howling in the background. So when the core is left, it is tens of millions of degrees. It is no longer fusing. It is just a hot bit of the star that's left over. But that's all that it is. It's just left over. There's no fusion. It is just slowly cooling off, and it will cool off over billions of years. But while it's cooling off, it is tens of millions of degrees. It is giving off a lot of ultraviolet radiation. And that ultraviolet radiation is causing the gases that just escaped the star to start fluorescing. So the gases, the hydrogen is fluorescing red. The oxygen here is fluorescing this blue-green color. So this is actually a fairly bright object in the sky. When it's small, but it's bright. And when you look at it through a telescope, a decent-sized telescope, about 10-inch and higher, you can start to see some of the color, which is really, really neat. Most objects, most nebula, they're just kind of a fuzzy, grayish color. You don't really see the reds because our eyes aren't that sensitive to red. Well, our eyes are rather sensitive to blue-green, and there's quite a bit of it here. So this object fluoresces blue-green. It's quite bright. Even in small telescopes, it really stands out. The reason why they're called planetary nebulas is because the first astronomers who saw them through telescopes thought that they resembled small planets. And they kind of do. They're round. When you look at a star through a telescope, stars are always going to be points of light. Doesn't matter how far away they are, they're always going to be points of light, except the sun. One caveat. When you look at planets and you zoom in on them, they look like little disks. They resolve to disks, not to points. planetary nebula resolve to disks as well, because they're fairly large. They're larger than their stars, uh, a lot larger than their stars. So these are gases that are blown out. So now we also have supernova remnants as another type of nebula. And so when a giant star explodes, everything goes out. The core may be a neutron star, the core may be a black hole, or the core may just blow itself apart too. But everything that was in the star is now spread out across the entire area. And other stars can cause the gases there to light up. And we call those, well, they're just supernova remnants. They sometimes have names. For example, in the Veil, we call it the Veil Nebula. It's a supernova remnant. There's the Witch's Broom part of the Veil, which is, because it looks like a witch's broom. And these remnants can have nebula names because they technically are nebula, but they're also being lit up by other stars. We don't typically see a supernova remnant that's not lit by something. So I need to drink a little bit. Ugh. Excuse me. I am dry. It's been a very hot day. Now at 1 a.m. it is nice and cool, but I have not drank as much as I should have. So I'm feeling a little bit dehydrated. Still okay. All right. What do we have? So we're looking at the ring on one side. We're looking at M13, the great globular in Hercules. That's just really, really pretty. I like this one. Okay. What else can we look at? If you have any suggestions, put in the chat. If there's any object that you have questions on, put it in the chat. We'll go through. 1 a.m., not yet terribly sleepy. M13, M45. Let's see. No, this is M. It says, it thinks it's over here. It's not. We're right there. Pretty close to exactly right there. Let's resync on M13. Mounts get off sometimes. Okay. What else can we look at? With the M4, it is higher up in the sky. We have Vega, we have the Satyr region, which might be a little bit hard to see. There's this NGC 7000, we're looking at that. There's Pan-STARRS, which is a comet. I don't think we have any bright comets right now that are visible, especially at this time of night. We can go back to the Milky Way. I'm trying to find a neat object. You know what? Let's do this. Where's M100? We didn't look at enough galaxies. We looked at M99 and a bunch of surrounding galaxies early on. M100. Where is M100? It is low in the sky. Yeah. Bernie says, what about M101? It should be higher. This one is in Orion. Yeah. M101. Let's do M101. Okay. This will be fun. So first, let's stop the live stack. Change it from 30 seconds to 2 seconds. Come back, M101, 01, and this is M101. I want to say this is the whirlpool. Confirm slew. We actually had a, let's see. We had a supernova there this time last year, May of last year. So, and if you check out the YouTube videos for the channel, I did actually do a video specifically about that. I was able to image M101 the year before, previous to the supernova, and then I was really lucky that I had captured it from a dark sky site. We were actually at Three Rivers Foundation that time, so I captured it before the eclipse. I captured it before the supernova, and then I was able to capture it again after. I actually had to use a remote telescope to capture it because our weather was not great in North Texas. So by using a remote telescope, I was able to see it. Tools, let's do deep sky annotation. Where are we? Okay, nearby. M101. How far are we off? 565 pixels right of image. Close. Yep. Then we'll do a resync. Plate solve and resync. Ah, M101. Okay, so this may be a decently sized galaxy that we can see. And well, that thing, thing failed target. Okay, fine. Fine. Let's do this. Could not sync. Fine, whatever. So let's do M101. Let's do the live stack. Okay, and we'll do clear and turn off annotation. Tools, deep sky annotations, get rid of that. And then we'll do M101. 2 seconds is not enough time. We need at least 60 seconds on this thing. Yep, at least 60 seconds. Let's see what happens. And we should be able to see it coming up pretty nicely. In the meantime, here's the Ring Nebula again. It's looking a little bit better. I think our guiding got a little bit better. But we can definitely see the central star. So, right there in the middle, that is the white dwarf that is lighting up the entire planetary nebula. Tens of millions of degrees. It is just, think of it like this. Think of it as a just a chunk of matter. Let's say you took a hunk of iron, took a big steel ball of iron, and you heated it up in a furnace, in a forge, and it got really, 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 really hot, white hot. Take it out, put it down somewhere. It keeps glowing for a period of time, and it slowly cools itself off. Hello, doggo. So for anyone joining us now, oops, we've got dogs. Hi. Want to be on camera? And then doggo. And hi. Smelled something he didn't like. Coyotes or something else. We've got dogs. They're actually the neighbor's dogs. There are 2 of them, and they like to come over, and they're very friendly. You've never had any issues with them other than them just wanting to get in. All right. Is 60 seconds not enough? I don't think it is. Total exposure should be kicking in any moment now. Here we go. Let's go back to camera 2. Any moment. It's adding in everything right now. Processing. Hello. 2 frames rejected. Okay, 6 stack, 2 rejected. So it's rejecting. Oh, probably. Well, yes, that would do it. How about this? How about this? And I think I have to recalibrate it yet again. Typically recalibrate for every part of the sky. Now I'm looking to see. Yeah. Normally, I would actually have the laptops pointed more towards the telescope, or actually the telescope off to the side, be easier for me to work with. but because there's so much light, I'm trying to throw this out away from everybody. That's why I turned off the red light. I want to try to bother people here as little as possible. And when we go off to do remote stuff, it'll be easier because everything's going to be inside the dome. I'll be able to actually remote into the dome and into a computer connected to the scope and the dome and control everything from here. And I'll be able to sit at home in my office at my desk and do a live star party where I don't have to drive 2 hours out to a dark sky site. It will be nice. We have a telescope and mount ready to go. Everything's just not set up inside. So once it is, everything is in there. It'll be good. I hope. Clear this out. Okay. Yeah, this is ugly, but let's give it a minute. Oh, there we go. Now we got a galaxy. I'm going to clear it because I want fresh frames. Oh, no, looking good. So we'll see what the next one's going to be. 17 more seconds. Okay. For a 45-second exposure, for a 60-second exposure. Okay. That'll work. Oh. I didn't have it switched over. All right, new stack, and we'll be at 22 seconds. In the meantime, what else can we look at? We have the ring. I actually had a list of. John's asking, is that the Ross dog? Yep, that's one of them. Corona Borealis to see if it went bang. I don't think it went bang. We would have heard that it went bang. And I'm not going to look at it on this one. Oops, hey, it just came in. I'm not going to look at it on this one because it's too small of a field of view. And over here we have a galaxy. Oh, we have another galaxy right there. We have another galaxy right here. Let's do this. Let's do our annotation. Remember, this is the first image, nothing else. Deep sky annotation. Cool. There's galaxy here, galaxy there, galaxy here. I think it's already off. Let's do another play solve. There we go. Now it's good. We have an H2 ionized region within the galaxy there. Some possible satellite galaxies, more galaxies all around here. That's pretty cool. All right, let's zoom in and take a look. Oops, not that. Zoom in. Go 200x. Ooh. Remember, I'm trying to get this in. Okay. Ah. Over in this arm, I think it was right here where we had the supernova last year. Right about there. Let's get this over. Yeah. So we have this ionized H2 ionized region, and then right in here is where we had the supernova. So we have another ionized region here, ionized region here, ionized region here, ionized region, ionized region. Yeah, these are basically just star-forming regions in this galaxy. Let's get rid of the annotation. I still have all my bugs here, but I want to say it was right here. Watch the video. If you watch the video, you'll see exactly where it was, but this is a really, really pretty spiral. You can see the arms are well defined. And what's neat about this is with spiral galaxies, the arms are density waves, and that's all that they are. So stars pass in and out of the arms as they travel around the center of the galaxy. And they just happen to be places where the stars bunch up. So the stars in an arm aren't in that arm forever. Very cold water. All right. Now, looking out to the east, I see nothing. My eyes are totally, yep, totally not adapted to the darkness. So I see nothing. But this is really neat. 4 minutes of exposure. We see a whole lot less noise. We see the extent, how far it goes out. Zoom out 100%. Yeah. We can see just how far out this galaxy goes. It probably extends a little bit further out. There's a halo around it too. But right here we can see the core, the bright center. We can see the arms are well defined. We have one arm that extends way out to here, maybe even out to here. This arm extends out to here, here, and here. The 3 spurs. There's one arm here. And this is all one arm. This one probably extends out this way too. But we see areas of star forming, brighter areas. This is a really large star forming area here. Then again, so is this, and so is this. They're very large. Wow. Then if we look over, we can see we got some artifacting there. I think it's the wind. Whoops. Yeah, guiding is not that great tonight. That's fine. I'm not really terribly upset. It ain't perfect, but Ooh, here we go. Here's a edge on spiral. So an edge on spiral is just like the name says, it's a spiral galaxy that we are seeing right on the edge. It's not tilted in any way toward us. So we're seeing it kind of like we see our own Milky Way. We see as if we're inside that plane. So here's some other galaxies. This is probably an elliptical. I don't think this is a I don't think it's a spiral. It looks elliptical. What is that? Oh, that's me. That's my fan in my PC. I need to deal with it. There's a galaxy. There's a galaxy. Remember, we're looking out into, well, away from the Milky Way. So this place should have lots and lots of galaxies. These little tails, this is from just an artifact of trailing. So I mean, I can clear it and hopefully get better images, but yeah, my guiding is so off. Not happy about the guiding, but that's okay. All right, are we still on? Yeah, we are still on the yeah, still on here. So I have not moved it off. Let's see, planets. Maybe we can do a planet. Let's see if Saturn is up. I don't see it, but let's go look at the map. So where should we be looking? Big there's Saturn. Saturn, Neptune. Okay. Saturn and Neptune. They are up. Oh cow. Move to Saturn. It's gonna be fun. I'm gonna do dump this light back. Change the time to be like 1 second because it'll be super bright. Okay, maybe not 1 second. I gotta do a I have to do plate solve on there. So While that thing is going, jump back on galaxies. Let's see what it looks like in the middle again. Yeah. The galaxy down below. Yep. And a satellite trail. Satellite passed right through. Fairly dim, nonetheless. Probably a polar. Looks like it'd be going in the right direction. Polar. Okay. Alright. What am I looking at? On this side. Ugh. Oh, yeah. That's Saturn? I don't think that's Saturn. Okay. What are we looking at? On that side. Try this again. So many bugs. That's the one thing I don't like about doing this kind of imaging in the summer, other than the heat. It's the bugs. There are bugs absolutely everywhere. Not enough stars. Can't find enough stars. Try it again. Still not enough stars on that side. Okay. 11 minutes. I don't think my guiding is very good tonight. Nope. Oh, it's way off. That's horrible. That's horrible guiding. But, it's good enough for observing, which is really what we're doing. And I don't know. I need to look at the Saturn is. And this doesn't look like Saturn. We have a little bit of wind. Yeah. Yeah, this is not working. Not working at all. Yeah, it's getting windier. Tell me what I'm looking at on this other side. Not able to quite solve. I'm trying, but it's not going. Okay. In terms of galaxies, let's see what other galaxies we can see. In the meantime, I need to take a walk around. Let's see. Galaxies. There are a number of galaxies in this area. There's M101. We're looking at that right now. Which one's this? M51. Yeah, do that. Turn off that live stack. 51. Alright. Switch it to 8 seconds. We can. Oops, auto. 8 seconds and deep sky annotation. Nope. M101. M51, sorry. Whirlpool Galaxy. Hey, yeah, let's do that. Whirlpool. Center in view. So it's a little bit off. Yep. I guess we're looking at the Pinwheel Galaxy, and now we'll be looking at the Whirlpool. Okay. Right. Let's do a 60-second exposure. Do live stack. Hit again. Clear it. That's the pinwheel. I'm 101 the pinwheel. Now we're looking at the Whirlpool. The Whirlpool Galaxy has a little satellite galaxy which it is gravitationally interacting with. We're going to give it just a minute. There we go. While I stand up. Not much to see yet. A couple more seconds. Hopefully it brings it in. There we go. Oof. All right, guiding is off. Let's fix the guiding. Yeah. Can't guide. Guide on that guy. Okay. Back to here. Clear it. Should be centered out right there. Need a couple more seconds before it appears again. There we are. Now we can see the Whirlpool and that little galaxy that it is gravitationally interacting with. Let's scroll this down just a little bit more so it's nice and centered. Ooh, we have a little bit of jumping. Hopefully it'll get cleared out in a bit. I'm going to clear it now. Wait for the next image to come in. There we go. That's much better. All right. So that looks pretty good right there. That's not bad at all. I'm going to take a little bit of walk around just to stretch out. Sitting here for the last several hours, this does not bode well for my back. I am not so young anymore. I need to go ahead and walk around for just a little bit. I will return. In the meantime, please enjoy the Whirlpool Galaxy. one foot in front of the other and keep going.
Well, I mean, right there, guys, it's funny. Oh. 151, right?
Yep.
152. That's good.
Very lovely. All right, we're going to go ahead and shut down one of the scopes only because I've got to return that camera. Because somebody can't spend the whole night out here.
You're welcome.
Thank you. I really appreciate it. All right, so we're down to one telescope left. I really don't want to bother connecting the other wide field scope at this point. I'm just tired. It is 1:30. Hard Rock Master is asking what type of power telescope is being used. And John is going to sleep. Good night, John. Okay, so this telescope is a Celestron C11 Edge HD. Normally this is a very high power telescope, except that I have a Hyperstar on it. The Hyperstar allows me to go from f10 natively to f1.9, which is a much faster scope. It gives me a much wider field of view. In fact, if I do a quick plate solve, it will tell me just how wide my field of view is. Almost 2.5 degrees by 1.66 degrees, and is 539 millimeters in focal length, or the equivalent of 539 millimeters of focal length for a full frame aperture camera. So this is basically like my Teleview 101 refractor, just 11 inches instead of 4 inches. Does it make a difference? Oh yeah. An exposure like this would have taken me, let's see, this is a 60-second exposure. This would have taken me probably minimum of 5 minutes on the refractor. Would it be a better image? Would it be sharper on the refractor? Maybe. I wouldn't have some of the diffraction spikes coming off of the stars that I do with this one because of the wires in front. But it is still, it's a very fast instrument, and doing this kind of live stacking now, it makes for a really good view. What the power is, I couldn't tell you. I don't calculate power. Not the way that you think about it. I'm looking specifically at what my field of view is, what my resolution of the camera is. The thing that really most concerns me is the field of view. It's what can I see? So with this one, yeah, this is what I'm seeing. The galaxy itself is pretty small in the field of view, but I'm able to see pretty good detail out of it. We're able to see the arms. We're able to see the dust bands in the arms. Check it out. Dust bands in the arms. All through here. These are dust bands. That's a dust band. We're able to see that. I can zoom in even closer. Yeah. How's that? Okay. Just trying to get some pixelation at this point, but you can make out dust bands in the other galaxy. So this is like a nearby stars. That looks like it's a region out there. this right here is a major star forming region around the core of this galaxy. And you got this big dust band through here. So this is all pretty cool. I mean, this kind of imaging that we're able to do right now, if you think about it, I'm sitting here at a dark sky site with, admittedly, a bunch of electronics all around me. But I have a camera now that I'm able to get better images on a random Sunday than we could do 20 years ago. 20 years ago, this was like something like this was pretty much a pipe dream. We were still using film for the most part. People who were using CCD cameras, that was all brand new, but they were fairly low resolution. Most of them, well, they were all monochrome. You'd have to use a red filter, a green filter, and a blue filter to get color images. And the scopes weren't as good. They weren't as sharp for the most part. Now, if you have the money, and it doesn't take a whole lot of money either, you can take images that 30 years ago, almost, well, not almost impossible. It was very difficult for amateurs at home to be able to take. You'd have to do it with film. You get one shot at it, and that's it. I mean, you're talking about doing exposures, like an hour-long exposure on a one frame of film, and just hoping that your tracking is good. We didn't have guide cameras back then. Literally, and I've done this before, you used a eyepiece with a glowing reticle on it that's being lit up by a small LED off to the side. And you sit there at the telescope and you look at the star. Once you have everything perfectly polar aligned, as close as you can get, you have it on a guide star. And then if you see it move just out of that little corner of the reticle, you have to gently move it back very, very carefully, over and over and over throughout the entire exposure, and then you close it. You close the shutter, and you hope for the best. You send it off to be developed, and you hope for the best. One of the doggies is just coming over. Yes, Hard Rock Master. It is a Schmidt-Cassegrain, but it is now a modified Schmidt-Cassegrain because I have the Hyperstar in front. If you Google Celestron 11 and Hyperstar, one word, you can see an image of it. So the camera being at the back of the telescope, so the light would come in on this side, bounce off a mirror, bounce off a secondary mirror, and come back to a camera at the back. Instead, you remove the mirror out in front, and you put in a lens assembly and the camera. So the light hits the mirror in the back, goes through the lens assembly, and hits the camera in front. That's what makes it an f1.9 instead of an f10. It's not. It's folded only in one direction now, instead of being folded twice. So it's yeah. The images are super, super good. I'm pretty sure I could tighten up the focus just a tad. But as it is, it's pretty good. I'm getting really, really good images. I'm fairly happy. It ain't perfect. It doesn't need to be. Not for what we're doing right now. This is a really, really good way to show the public the kind of stuff that we can do. The only problem is it's at 1:38 in the morning. So you can't really do this during the day. I have friends in Hawaii right now who they are, I think, 5 hours behind. So they're at 9 p.m. They're just now getting ready to go to bed. Or if they're going to be doing some observing or imaging tonight, they're just now setting up outside to do imaging. So they're setting up their scopes outside. But here it is getting pretty late, 2 a.m. In order for me not to fall asleep in the car on the drive back, I will take a nap before I head out. But there's going to be a lot of packing this morning too. But that's okay. And people are still out there imaging. Most people have already left. So, but I really want the new observatory to be up and running soon. The scope and the mountain there, so that I will be able to do this remotely. I have figured out how to do this remotely at home, but at this point, it's just it takes a while to get everything set up. I'd love to have my own observatory. I have a place to put it. It's just a matter of finding the time to do it. There's never enough time to do it, and finding a dome too. But it takes about. It took me more than 2.5 hours to get set up today. So if you think about it, if it takes you over an hour to get set up, and then it takes over an hour to break down and put away, you don't want to set up unless you're absolutely sure you're going to have a great night doing it. And for us, driving out here 2 hours to get to our dark sky site, it is a significant investment. It's 2 hours out, 2 hours back. That's 4 hours. And if you only stay here, 3, 4, 5 hours, is it worth it? Most people try to stay the entire night if they can. And others are already heading home. So they'll get home about 4 in the morning, be able to get in, 4 or 5 hours of sleep. They'll be able to get up early Sunday morning, and they'll be fine. I've got so many bugs. Every single screen is covered in bugs. Actually, strangely enough, these two screens are not covered in bugs. They just have one. It's the laptop screen. I wonder if there's something different. I'm using portable monitors on the stream box. I have a separate computer just to do the streaming. And that is because I learned that if I don't do that, and something happens with the computer that I'm using, the stream will go down. Alright, let's see. There should be a galaxy over here somewhere. Where did we miss it? Hello, doggo. There we go. There's an elliptical galaxy. Hi. Here's a doggy. Ooh, heterochromia. One eye is brown, one eye is blue. Pinky breath. Ooh, both doggies. Oh, come on. This side. Other side. Here we go. This side. Yeah. Hi. Doggies are fun. So we're looking at the elliptical here. I want to zoom out again because there was like another fuzzy one somewhere. Maybe it was a different image. I think we're looking at a different image. There's that elliptical right there. So we've got a good 16 minutes on this one. All right, let's find another galaxy. Hey, I've got to look for galaxies. I know, you just like scritches. What else can we find? What else can we find? I know this says Fort Worth, but it's off. M51, M62 is low. Let's see if we can hit it. What is it? Oh, yeah. Hey, we want to do that one. M63. Flew to M63. We're going to stop this. Yeah. I want M63. Blah, blah, blah. Whatever. Okay. Yeah, guide on that thing. M63. Want to do stop that live stack. Do a new live stack. No. Stop. I want to do tools. We're going to do another plate solve. I want to know what we're looking at every single time you do a plate solve. Now, the neat thing about the plate solve is I can do this fully remotely. I don't have to be at the location. I don't have to do the full alignment if I don't absolutely have to. If I don't want to. I don't need to. Oh, 60-second frame. Let's do that. Let's do 15 seconds. Yeah. Faster. I gotta do 4 seconds. Let's do a 4-second exposure. Okay, it knows where I am. So let's do this. Tools. We're going to do deep sky annotation. Let's do plate solve and resync. I think failed. Fine. What are we looking at? Where do we want to be? Where do we want to be? Yes, fine. M62, right? M63. Cool. So we can do this. Messier 63. I will do this within the app. 63. M63. Confirm. No, that's not what I want. Okay. M63. Back to here. Tool. Plate solve. Okay. Tool. Plate solve and resync. Please let it resync. Cool. No. Fine. Whatever. Fine. We'll do this. Tools and deep sky annotation. Then what I'm looking at, 1, 2 galaxies and some stars. Okay, so we're going to go nearby. So many. I see targets, I see catalogs. M63, the Sunflower Galaxy. Let's do that one. Where is it? Oh, wow, it's off, way off to the side. Yes, 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 recenter it. The Sunflower. There we go. Okay. Let's do a 60-second exposure on the Sunflower. 90 seconds. Let's do 60. In the meantime, clear. There it is right there. It's that fuzzy. Sleeping. Got on that guy. Back to here. Okay, it could be somewhere over there, so let's just do live stack. Clear this live stack. That's the old one. All right, almost there. Bingo. Ah, freaking. It's wind. I have a little bit of wind. I'll clear it. Let's wait for next one. But yeah, we got a little bit of wind. Not a big deal. Ooh. Can't just sit here for hours and hours and hours. Got to move. I have a car that is likely full of bugs because I left all the doors and windows open. So it should be fun tomorrow when I drive away and have to open up all the windows on the highway to blow out all the bugs. Unless, of course, they found places to hide between boxes and everything else. And why do I suddenly have ants that are biting me when there were no ants here before? Okay, here we go. Sunflower Galaxy. Let's zoom in on this. And it will start looking better and better and better. Oh, what is that? That's a satellite. Ooh, there's a galaxy. There's a galaxy. That light goes right through the sunflower. Okay, well, that'll get cleared up and we'll fix it in post. Used to say. So this has a bright core, and then it's got these, I think it's called flocked arms. Waiting on one more, 14 seconds. Yeah. Let's see what it does. Now I'm going to go take another walk. In the meantime, I'm going to do this. I am going to disable the noise suppression. Now you can have all the cricket sounds you can want. A little bit of wind noise. I don't know how much of the wind noise you can pick up, but yeah, so the noise is dropping down. We'll be able to see a little bit more detail in here. So I'm going to go take another walk while this thing is coming in. So enjoy the sunflower galaxy. I'm back. I can't see anything now. My eyes got a little bit adjusted, but the sunflower galaxy is looking quite nice. Well, I had a little bit of stutter there, so not as nice as I thought. You can see a little bit of stutter in the stars here, especially the bright one there. That's not good. But didn't affect the galaxy terribly. It's the wind. The wind picked up a little bit, so. Okay. It is now 2:07 a.m. I think it is a good time to stop. We've seen quite a bit. You got to listen to a serenade by the crickets. Turn that off for now. But it is late. It is pretty late. It's 2 a.m. It's a nice cool wind. At least it's not hot. I am going to. I think I'm going to eat something. I haven't eaten anything since about 12 hours ago. So I'm going to eat a little bit, and then I have a cot right here, right next to me. I'll get that set up. I will take a short nap, and then I will get up before sunrise and start packing up all this so I can head home. It's been a very, very long day, very, very long night. Thank you for sticking around till 2 a.m. So it's been a fun 4.5 hours, roughly. We did get to see some good objects, so if you want to, you can always go back through and watch the stream again, pick up the highlights. We got to see, let's see, from the beginning, we got to see several galaxies in the west before they set. Then we moved off to the Milky Way, and we looked at we looked at M4, a globular cluster right next to Antares. We looked at the Lagoon Nebula, Messier 8. We looked at Messier 20, the Trifid, Messier 16, the Eagle. Then we moved off to the North America Pelican, which needed more exposure. We looked at Messier 13 in Hercules. Then we went over to Messier 100, I believe, Messier 101, and Messier 51, and now Messier 62. So we did a number of galaxies. We did a number of nebula in the Milky Way, a number of clusters. Oh, and we also did the ring nebula M57. So we saw globular clusters. We saw some open clusters in the nebula. We saw some various nebula. We saw a planetary nebula. We saw star-forming nebula. We saw emission nebula. We saw reflection nebula. And then we went off to see galaxies. We saw a lot of galaxies. In one of the images, it was lousy with galaxies. They were absolutely everywhere. And we would see galaxies when we looked at M13. We saw quite a bit. So I'm pretty happy with how today ended up being. The heat wasn't great before the sun went down, but since then it's been fairly cool. It's been a nice night. So I'm going to go ahead and sign off. Thank you for joining us. Again, I'm Chris Morgitsky with the Fort Worth Astronomical Society. If you do live in the Metroplex and you'd like to join the club, there are instructions on how to join at fortworthastro.com. You have to hunt for it in the membership section. We have a sign-up sheet on the Night Sky Network from JPL and NASA. We are a 501(c)(3) nonprofit organization. Anything you care to donate to us, you can take off of your taxes. I am here tonight at the Rising Star Observing Area. This is a Fort Worth property that we just got power and internet to. And it is our land now. Finally, we have a piece. And it is located between Cross Plains and Rising Star in Eastland County in Texas. If you would like to come out here, you will have to join the club. or come with a club member as a guest. Our dues, I believe, for a family are $60 a year. And it gives you access to the dark sky side. It gives you access to the telescopes that we have in storage. It gives you access to actually borrowing the telescopes. One of the telescopes here, the Celestron C11, I am leaving here because this is a club telescope. So if you come out here and you would like to use the Celestron 11-inch Schmidt-Cassegrain, feel free to. It will be in the back storage room. Once our new storage building is complete, it will be moved there. So it is a large telescope, it is a heavy telescope, but it works just fine. It has a remote focus motor on it. And honestly, I have had it in my house now for the last 4 years. I am going to be glad to get it out because it is big, it takes up space, and I have my own C11 as well. So again, my name is Chris Monitsky for the Fort Worth Astronomical Society. Thank you for joining us, and good night.